Dear participants, good afternoon. I would like to say welcome to all of you. Now we will start our keynote speaker session, and I will give the screen to first our Dean, Süleyman Toy, and then Daphne will explain something.
Yes, thank you very much, Dr. Doğan Dursun. As you said, we are now at the last session of our symposium, and I want to present my thanks again to all the participants and all the scientists and all the presenters. So our last session, we have a valuable group of keynote speakers from Turkey and out of Turkey. And if you have permission, I want to give the floor to our valuable Professor Osman Balaban, whose speaking topic is climate change and cities. Then after the first speech, I will give the floor to the other other keynote speakers. And Dr. Osman Balaban, please, floor is yours. And thank you very much for your participation.
Thank you, Hocam. Süleyman Hocam, thank you very much for this kind introduction. And also, I would like to thank to the organizers of this conference who gave me an opportunity to express my ideas and viewpoints on this very important topic. And as you mentioned, I will today talk about the relationship between the climate problem and cities, and I would like to highlight some major challenges of local climate policy with reference to some of my observations also with reference to my observations with regard to the Turkish cities and the Turkish context. And I have a couple of slides to show, so let me try to share my slides. I think the slides are reflected on the screen, right? Any problems with the slides? Can you
No, we can see.
Okay, yeah. Thanks again, and also I would like to say good afternoon to the participants. And as I mentioned, I will try to highlight some challenges of addressing the climate problem at the local level today. And in the first part, I will kind of try to link the cities and city administrations with the climate policy, because this issue, the link between cities and climate policy, is one of the main facts of international climate policy today. And we mostly, the international community, when you follow the recent climate change debate, you'll see that the international community widely acknowledges the roles that cities and city administrations can play to address the climate crisis. And today, the urban actions or city-based actions constitute an important dimension or pillar of climate policy. And some recent international policy documents also highlights this fact and highlights the importance of cities. Like, for example, the Sustainable Development Goals agenda has a particular goal on cities and urban communities, like the SDG 11 underlines the importance of cities and communities for a sustainable future where climatic risks are also minimized. And the Paris Agreement is quite different from the Kyoto Protocol. And one of the differences between Paris Agreement and Kyoto Protocol is that Paris Agreement also recognizes the importance of local level, cities and local governments. And it emphasizes the fact that local governments can play some crucial roles or can put in place some important actions to reduce global emissions and also reduce vulnerabilities to climate change. And in a similar direction, the UN General Secretary Antonio Guterres, in the C40 World Mayors Summit in 2019, he argued that cities are the forefronts of climate change battle. It's cities where we are going to win or lose our fight against climate change. And he also stated mayors, local officials, as the first actors to respond to this problem. And in 2018, IPCC, the major scientific, let's say, mind behind international climate policy, organized for the first time a conference which is directly focusing on the cities' inclusion in climate policy, the Cities and Climate Change Science Conference. And as far as I know, a special report on cities and climate change will be released soon. It will clarify the links between this problem and urban areas. All these recent developments are highly plausible and make sense when we consider the city's position, urban areas' position in the emergence and the experience of the climate problem. Most of the greenhouse gas emissions are coming from cities. And on the other hand, cities are the places where adverse climatic impacts hit. And cities are the most vulnerable among all other human settlements. Cities are the most vulnerable against climate change impacts. And the graph on the left side tells us an important or informs us about an important fact. It argues that, or it indicates that by 2050, by the middle of this century, because world's population is increasing and most of the world's population are now located in cities, and building the infrastructure, the urban infrastructure, like the roads, transportation system, buildings, so on and so forth, in order to build the urban infrastructure to accommodate the future population in cities of global south, will release 4 times the carbon dioxide, which was already released to create or to build the existing urban infrastructure in the global north. Plus, many cities in many parts of the world today are experiencing various climatic impacts like floods, heat waves, extreme weather events, sea level rise, so on and so forth. So, in order to avoid this issue, one of the things that we need to do today is to change the ways we build our cities and manage the ways we manage our cities, not only in energy terms, but also in terms of resilience and safety. So this fact makes urban areas the priority sites for climate change mitigation and adaptation actions. And this is an ongoing agenda. And we have been discussing the inclusion of cities in climate policy for some time. And some cities have already engaged with this agenda, and they have been following a sort of municipal activism to solve this issue. And this experience, the experience of including cities and local governments in climate policy, today provides cities and city administrations with a range of actions and policies to be put in place in cities, in urban areas. In a recent study, the authors grouped these actions, likely actions or policies, in 3 categories, which I think make important sense: technological solutions, nature-based solutions, and social solutions. And the technological solutions, by the name or by the term, it is based on the introduction of new technologies in various urban sectors with the aim of increasing energy efficiency, with the aim of replacing fossil fuels with renewable energy, and also facilitating or helping cities become more resilient and safe places against climatic impacts. And these sorts of technological solutions range from electric cars to building energy management systems or early warning systems for extreme weather events, rainwater harvesting systems, so on and so forth. Nature-based solutions, they kind of are based on the idea that we should bring more nature and ecological areas back into the city space. And this can be done by replacing the man-made urban environments, man-made urban greenery, with natural and ecological ones to the largest extent possible, as much as possible, by means of green and blue infrastructure, and also by means of restoring the already degraded ecosystems within cities. In order to implement extensively these technological and nature-based solutions, societal acceptance is must. Societies, urban communities should accept these ideas, and also should behave in line with this agenda. Therefore, social policies are there for this kind of community or societal acceptance. And social solutions include various programs, initiatives that aim to increase or raise awareness and facilitate behavior change and reduce inequality among different community groups, social groups. And these solutions, the technological ones, social ones, and the nature-based ones, they're highly complementary. They can talk to each other, and they can be coordinated. And a combination of the integrated solutions can also be possible, like integration of all these three, or integration of different of these solutions. For example, green roof systems. They are a combination of technological and ecological solutions. They are ecological in a sense, but in order to put these ecological solutions in place, you need to have a certain level of technology development. And they can be regarded as techno-ecological solutions, which can deliver multiple benefits, like natural cooling of buildings, green space connectivity, food production, reduction of urban heat island effects, so on and so forth. The thing is, okay, we have this know-how and we have this experience. However, in my opinion, there is still an important question needs to be answered. Despite all these know-how and experience, are cities and local governments prepared to perform the roles expected from them to tackle the climate problem? Can all cities, or is the local levels ready to benefit from this experience and put these solutions in place effectively? In my opinion, we cannot give promising answers to this question. And there are still many challenges that kind of hinders or prevent local governments to benefit from this experience. And from this point onwards, I would like to highlight some of these challenges. And here I will also try to refer to what's happening in the Turkish context, in the Turkish local context. One issue that I would like to mention here is the challenge of local governments. And I have talked about a range of policies and actions which can be put in place at the local level in cities. And in order to put these urban climate actions in place, apply them, implement them, develop them further in localities, we need to mobilize a range of resources: monetary resources, financial resources, human capital, people who can understand these solutions and tailor them into the local context. We need to have a certain level of know-how, institutional capacity, so on and so forth. So this fact, in my opinion, requires strong local governments, empowered local governments, but not only in financial terms, strong in financial terms, strong in administrative terms, strong in political terms. So we need financially, administratively, politically strong local governments, local authorities, or city administrations. But when you look at the current or the existing situation in the world's countries, in many contexts, local governments are quite weak. The political systems are highly centralized, and local authorities, and this is very much the case for our country, for Turkey. Local authorities are weak, and they barely cope with their conventional responsibilities, the traditional responsibilities. And Turkey is an example. Turkey is a centralized country, and local authorities are not provided with sufficient resources to deal with the traditional responsibilities, along with address these contemporary environmental challenges. And to exemplify this issue, this challenge, I will try to refer to two fields of urban policy which are very much important for climate policy as well. The first one is urban regeneration, urban renewal, and the second one is transportation. In most Turkish cities, the low quality and decayed or declined, deteriorated urban quarters is a common problem. In most of our cities, the existing urban cores, and this is more valid for mid and small cities in Anatolia. And existing urban cores are quite old and they need renewal, they need regeneration. Therefore, urban regeneration and renewal of already worn, decayed city parts, city quarters, inner city quarters is an important policy target for Turkish cities. And this is also highly important for addressing of climate change at the local level, because if you can manage to renew or regenerate inner city quarters in a kind of comprehensive manner, you can increase energy efficiency, you can make these urban quarters more energy and resource efficient by means of better building construction, by means of centralized heating systems, by means of better insulation, so on and so forth. So you can increase energy efficiency, and also you can put in place public transportation and non-motorized transport options here. This can also add to the energy efficiency, but you can also make these inner city parts more resilient and safer against climatic impacts. So this is an important agenda for Turkish cities. However, our local authorities, Turkish cities, they lack the capacity to follow this sort of an urban and climate change agenda, because municipalities, they do not have available budget to finance urban regeneration projects. And also, if they may not have the budget, but they can have some institutional tools, instruments to benefit from alternative financial mechanisms for regeneration, but these sort of policy instruments, policy tools are also not very available. They are highly limited. So what do Turkish cities, municipalities do in order to accommodate the upcoming population? They usually open up green fields for urban development. Cities are developing by expanding their built-up area to peripheries, and this the outcomes are obvious. You cannot solve the problems of existing cities; the problems remain untouched. Greenfields are open for urban development, and cities sprawl and travel distances increases. This is a kind of maladaptation to the climate change agenda. And this situation is also same for urban transportation in Turkish cities, because Turkish cities are usually poor in provision of especially rail-based transportation systems, public transit systems, and also non-motorized transport options like walking, cycling is not a structured urban mobility option in our case. Therefore, Turkish cities need to make substantial improvements in urban transportation by means of providing multimodal public transportation systems, which also includes non-motorized transport options as a structural mobility option in that city. However, even large metropolitan cities lack the capacity to improve their transportation network. They do not have sufficient financial, administrative capacity to provide extensive rail-based or bus-based transportation transit systems, and also make the infrastructure appropriate for non-motorized transport options. So the challenge of local governments, weak local governments, or let's say, is a major challenge of local climate policy. Another issue that I would like to highlight here is the challenge of shrinking cities. Some cities in many countries, in many nations, also developed countries are part of this problem. Some cities are in a disadvantaged position compared to others. And shrinking cities is a good example, because shrinking cities are suffering from various sorts of decline. Economic decline is an issue. Population decline is an issue. Not only their population decreases, but also they are losing young and high-skilled population. They are moving from shrinking cities to other cities where they can have better living opportunities, and decline in municipal revenues as the economy is not functioning well. So this also adds to their revenue problems, and municipal revenues decline. Populations are becoming old. Their aging of population is a problem. And in several cases of shrinking cities, when you look at the global scale, local economies of shrinking cities are highly carbon intensive. They are based on fossil fuel industry or carbon intensive industries, and their energy patterns are fossil based. Therefore, in shrinking cities, in order to address their already existing problems and to make them, let's say, climate friendly, climate neutral, and climate resilient places, in order to achieve the transition to a carbon neutral and climate resilient urban structure, you need significant amount of resources. However, these financial resources are missing in most of the shrinking cities, and it's really difficult to find these resources in the near future. Zonguldak is an example in Turkey. Zonguldak is a leading example of shrinking cities in Turkey. And the local economy of Zonguldak is based on carbon-intensive sectors like coal mining, iron and steel production. And the city is losing its population. The economy is not performing very well in the last several decades. And to make Zonguldak a carbon neutral and climate resilient city is a difficult task, because it needs economic and energy transition actions and policies. And these are really difficult to develop and implement in the city of Zonguldak, because municipal finance is highly limited. And also the city is losing its young and high-skilled population. And under these circumstances of difficulties, financial difficulties, social and demographic difficulties, new tracks of local economic development cannot be opened very easily in the short term in for example, Zonguldak or other shrinking cities. So this issue should remind us the just transition mechanism of the EU Green Deal. Cities like Zonguldak should not be left behind, and therefore regional policy frameworks, national policy frameworks should pay important attention to these sort of cities and favor them in order to make them capacitated to address their problems along with the climate policy. Not all cities are shrinking, and there are small cities, and small cities are also in a very disadvantaged position when you look from the climate change perspective. Their sizes are small, and they face important difficulty in climate change policy, because they cannot easily learn from the leading international examples. Because most leading international examples are kind of mid-sized or big cities, and the solutions that they have already employed in their contexts require certain level of settlement size to make policies and actions feasible, and to achieve economies of scale, so on and so forth. So their solutions require certain level of settlement size and also municipal budget. And small cities, therefore, cannot easily adopt such solutions. And this challenge is quite obvious in the transportation sector, because small cities, their sizes are not appropriate for example, rail-based transportation options. They cannot easily develop LRT systems, metro systems, because the size is not appropriate. And these sort of mass transit systems will be unfeasible in these cities. Therefore, they have to improve their road-based public and private transportation systems. And there you have the opportunity to shift to electric vehicles or vehicles that run on cleaner fuels like hydrogen, so on and so forth. And current costs and management barriers of this shift are also remarkable and important and difficult to overcome in the short run. Another issue that I would like to mention here is the challenge of climate urbanism. As I mentioned, we have an experience of municipal activism for climate change for the last couple of decades. So there has been some experimentation of developing and implementing actions and policies to address climate change in cities, especially in the global north. And in the literature, these urban climate actions are criticized. They are criticized for being market-based and technology-driven, profit-oriented, and they are also criticized for strengthening the already existing inequalities among different social groups. And this also underlines an important danger, the danger of protecting the already advantaged groups and also sacrificing the already disadvantaged groups by means of climate urbanism experiments. And this reminds us the issue of financing the climate change actions. As I mentioned, municipalities require important financial resources to address the issue, and their self-revenues are not enough. Therefore, they are in search of alternative funding options, opportunities. And there, if the money comes from private sector, naturally, profit-making and market-based strategies, profit-oriented strategies becomes a priority. And there is a danger here that these sort of profit-oriented, market-based strategies may sometimes fail to eliminate the current injustices, inequalities, and also they may create new ones. This is also an important challenge to consider. The last challenge that I would like to mention here, and I'm also approaching to the end of the time allocated for me in the program. And the last challenge that I would like to mention here is the challenge of the local community. In many countries, especially in the global south, in countries like Turkey, for example, urban communities or community groups, they have to deal with various challenges, and they are exposed to various risks, including economic challenges and risks, including social challenges and risks, including health challenges and risks, and also the environmental ones. Think about the situation in the recent situation in Turkey. Economic issues are pressing day by day. Unemployment rates are increasing in cities. People are losing their jobs, or even if they preserve their jobs, their income level is decreasing. The costs of everyday needs are increasing, like shelter. The cost of shelter is increasing, food, transportation, so on and so forth. So this highly influence the low-income families, low-income households, and many low-income households, they are very much concerned about their future, and they have to make a kind of priority list of their immediate needs to be more, let's say, sure about the future that they are waiting for them. And in those priority lists, one would not expect to see climate change on the list or on the top level items of the list. Therefore, immediate concerns of local communities for making the ends meet are unsurprisingly favored over future concerns on climate change adaptation. If you are not sure about the meal that you are going to put on your dinner table tomorrow, climate change adaptation is truly and unsurprisingly is not an issue for many households and local communities. So this is also an important issue to consider. So, okay, cities are the priority sites for addressing climate change, and they are in a really important position, but this is easier said than done. Many challenges are today prevents cities and city governments to take positive progress in climate policy, and they have to be considered, and they have to be, and research and also policy-oriented research in countries should really focus on these challenges and find ways to overcome these challenges. Otherwise, we cannot address the problem. So this list, the list of local challenges, can be expanded. We can add different items to this list. But these challenges have to be addressed, have to be solved, have to be resolved. Otherwise, our fight against climate change may not be successful. Therefore, national governments, if they are really sincere to address this problem, and if they are really willing to follow up on their commitments to Paris Agreement or the international agreements within the framework of climate change governance, they have to take actions to overcome these sort of local challenges. And empowering of local governments and empowering of local communities is a key here, is an important policy option. Therefore, centralized political systems should immediately consider decentralization programs and also should consider some sort of local government reform. And this is very much the case for Turkey, I think, but I'm not very hopeful. And Turkey is not promising. And recently we had this climate council, the National Climate Council, and I went through the 25 conclusions of the council with regard to local governments and local climate policy, local governments task force. And within these recommendations, I didn't see any mention of strong local governance. There were many things referred to, there were many things emphasized and mentioned, but local governance reform or strong local governments were not included in those recommendations. I hope I'm wrong, and I hope the situation can change in future, because if we cannot strengthen and empower our city administrations and local communities, we may not be able to achieve our targets in the climate policy, like the zero carbon target by 2053 of Turkey, and so on and so forth. So this is all what I would like to discuss with you today. I think I'm kind of within the limits of the time allocated for me. I really appreciate all of you for listening, and if you have any questions, I can take right now or maybe at the end of the session. And these are my email addresses. If you would like to have further contact with me, please feel free to contact me through my email addresses. Thank you. Thank you again.
Thank you very much, Professor Balaban. And as you say, if you have any question, we have 2 minutes time, and we can take the questions. But if we don't have any question, we can proceed to next keynote speech. Yes, we have a question. Dr. Defne Dursun, please.
Yes. Hello, Professor. You highlighted the importance of the strength of localities so much here, but I wonder now, what if they had this strength? Can we, in all the world, I know we can't do it in Turkey now, but thinking about the other localities in the world, can we produce the knowledge about these climate issues and in the other sectors that affect these climate issues, to lead the design and implementation of these possible and required interventions? Can we produce this knowledge? Do we have this? Okay, I can say that.
Okay, I mean, as far as I understood the question, I mean, okay, the providing or empowering local governments is the first thing to do. But this doesn't mean that local governments will be on their own from that point onwards. So there is this multi-level governance. Local governments will be in touch with their national governments, local governments will be in touch with the international community, and also local governments are in touch with other local governments globally by means of this transnational municipal networks. Therefore, know-how can come from various sources. We can or the municipalities can really benefit from the already existing multi-level sources of know-how. And the know-how is still diffusing, as far as I see. The know-how is still diffusing to localities. But the problem is the capacity which is required to use this know-how, to tailor it into the local context, and the financial capacity to follow this know-how is a problem here. And this is the first thing to be done. But I understand your question, but I think we already have some opportunities that can be used to overcome this issue.
Thank you.
Thank you very much for your answer. And another question, we have another question, Professor Andreas MATZARAKIS. Please ask your question.
Thank you very much, Osman. You focus mostly, let me say, on a top-down approach. What about the possibilities in Turkey about bottom-up approaches? I mean, participation process from population, organizations, and so on.
Yeah, thank you very much, Professor Matzarakis, for the question. In fact, I didn't mean or intend to look or follow a top-down approach. I was trying to mention the need for increasing the local capacity for better bottom-up approaches. And the things in Turkey right now, in terms of participation and so on and so forth, for big cities, for metropolitan cities, the situation is promising. The local community is becoming more and more aware of the problem, because in the recent years in Turkey, the cities and local communities suffered a lot from climatic impacts like heat waves, floods, and this summer forest fires influenced an important part of Mediterranean Turkey. So people are kind of aware of this issue, and local governments are becoming more and more aware, because at the end of the day, it's local governments who have to deal with the problem. Therefore, there is this kind of awareness, and things are promising things are happening in big cities, but in small and mid-sized cities, as I mentioned, the current problems of the local communities are more pressing. People, especially under the economic circumstances, there are many households, especially the immigrants, Syrian immigrants and the recent immigrants coming to Turkey, and there is a significant amount of low income or disadvantaged communities in Turkish cities who are very much interested in what they are going to put on their dinner table the next day, or how they are going to satisfy their children's needs. Therefore, climate change is not on their priority list, and which is highly understandable. So this is also an issue. There are promising things going on to increase the bottom-up issues, but there are also some important problems which kind of hinders this sort of a bottom-up, let's say, activism. But in big cities, things are more promising recently. I don't know if I could respond to your question.
Thanks.
Thank you very much again for the question and the answer. So if you want, we can proceed the next speaker, who is Professor Andreas Matzarakis, and he is speaking about the application of thermal indices and modeling in human biometeorology. So floor is yours, Mr. Matzarakis.
I hope that you can see my screen.
Yes, okay. We can see.
Yes. Okay. Thank you very much, Suleiman. Thank you very much for the introduction. Thank you very much also for the invitation. It's a pleasure to talk today to you. I want to say some words about my person. I have studied meteorology, but very early in my career, I started with biometeorology, especially in the last 20-25 years, focusing more on human biometeorology. And as you can see on the title here, it's a very technical title. I selected this in that way, but I, of course, will focus on specific things. And one of these specific things will be how to deal with the most emerging situation that we have at the moment, but we will also face in the future, which is heat. And that means, how can we describe heat? When we look on the activities and the actions that we had in the last 10 years or more than 10 years, we have a very interesting activity concerning the effect on heat, especially on humans. With this is the Global Heat Health Information Network. We see that there is a specific focus. And as Osman mentioned before, most of the people live in urban areas. That means heat in the city is not only complex, but very, very interesting. And there's also a secret why we want to deal about heat in the city. And the second is nothing else than that cities are warmer than the surrounding about in an annual manner about 2 to 3 centigrade. And this is not the secret, but the secret, and maybe also the communication aspect in that, is that at the moment people experience heat in urban areas in the same amount how climate change will be in the future. That means people in the cities suffer at the moment more, and in the future this will be 2 times. That means the concentration on the actions that we are running at the moment is mostly on heat in the city. Another possibility that we have here, and this is also a huge issue, this is heat in the workplace. And the other point is what we are doing during our free time, that means our recreation time or leisure time, how to quantify heat waves in terms when we are not working. That means during the period when we have free time. That means for sport activities or watching games and so on. This is exactly the issues that I would like to address here today. And my contents will be in that way. I would like to present you very shortly the methods that we have in order to quantify heat, because mostly we focus on air temperature, but we know that temperature is not the only one meteorological parameter in order to quantify heat. We have humidity, we have also other factors, and then we have combined effects and so on. And then I would like to present you some specific tools, how to run these approaches, these possibilities that we have, and then finally about the challenges that we have in order to apply these methods, and also how to sell these products in reality, visualize or communicate this information. This is my aim, and I would like to start with a methodology. And we have in terms, in order to quantify human thermal bioclimate, or in general we call this urban bioclimate, or we can call it also human biometeorological quantification and so on. But in reality is quantifying cold, thermal comfort and heat stress. We have several approaches. The one is when we look on that on a thermophysiological basis. That means if you look from the medical side, what is the absence of impulses on the receptors on the human body and so on, and how the people can react on that. The second one is to take energetical aspects like the body temperature, sweat rate and so on. And the third is in order to ask the people psychologically, that means information about the state of mind that expresses satisfaction or, let me say, stress in a thermal environment. That means we have several approaches, and then we can combine and then can assess this. To be honest, we have about 70 or 80 parameters who affect the human body in terms of heat, cold, and thermal comfort. And when we combine all these effects, finally, we going back when we want to analyze these conditions and can reduce most of the 70 parameters down to 6 or 7 parameters or factors. That means we want to quantify the overall effect on the thermal environment on the human body. We don't use not only air temperature, we use also the other parameters which are important for the human body, which is humidity, wind, but also radiation, which is very complex because we have several kinds of radiation. Mostly we focus on solar and terrestrial radiation. And this is in a very complicated because we have to look this, because this human body is 3D, we have to analyze this also in a 3D sense. So, and then we require also information about thermophysiology. Mostly we summarize this in activity and clothing. This includes more factors, but it can be optimized in these 2 factors. And then we see to the human body, or we take the human body as an engine who is producing energy and also releasing energy, exchanging energy. If we lose too much energy, then it's cold. If we get too much energy, then we feel heat. And based on the human energy balance of humans, we have the possibility to describe an thermal index, which is something like an equivalent temperature. That means quantifying all these above factors and giving the expression that we have, also the perception that we have in terms of a temperature. And we have some of them. What we are doing, we are exposing ourselves outdoors on a specific situation, how the human is standing there. And we are surrounded by the different meteorological conditions. And we calculate from the human energy balance, we calculate the core temperature, skin temperature, also sweat rate, and so on. And that what we get is some information about human energy balance. That means any watt per square meter and so on. And this we cannot sell to the planners or to the responsible people in administration. We transfer all this information in the indoor and describe the effect of the outdoor in the indoor in terms of an equivalent temperature. And that what we have in the indoor conditions is a real field temperature, but including all the other factors. And we have several indices. And the index that I will use for you today and I will present you is the physiological equivalent temperature, and about 20 centigrades means thermal comfort. We have many of thermal indices, as I mentioned, and there was some papers where they bring together all these indices and quantify them, analyze them. In reality, we have more than about 200 indices in this context. That shows the complexity, but it shows also that it's difficult in order to apply and quantify them. One of my former PhD students, he analyzes this in the context of a German engineering society guideline, and he brings all this information together. And finally, from these 200 indices that we have at the moment, we summarize them when we want to apply them for human biometeorological studies, including epidemiological studies. But when we want to have comprehensive information from cold, for the level of cold or very cold up to very hot, we have only 5 indices finally. And these indices have been implemented now in this new guideline. There has been a guideline 1998 where they recommend only PMV and PET. You see PMV is not anymore recommended. That means we have a method. We have this concept of the equivalent temperatures, and we can apply them in a very interesting, in a very comprehensive manner. Good. What kind of tools we have? How now we can run these thermal indices? We need, in order to run them, data. It is not a simple equation. No one of these indices is a simple equation where you can calculate in Excel. That means it's a complex model, and then we need also statistical analysis and also visualization. That means, first of all, we need data. We have several kinds of data. The data can be measured data, and we have several kinds of stations. We have also low-cost sensors, which provide data. Maybe they are not the best solution, but maybe also they can provide some interesting data. And then we have models. And the models that we have here, you see on the right side on this picture, this is a paper published last year in Sustainable Cities and Society, which shows what kind of models at the moment are used and how these indices, these models can calculate these indices, can be applied. So we see that we have only not so much models who can calculate all these indices. And at the moment we have very good models like ENVIMAT, Raymond, Solveig, or Skyhelios. You see the models, which is the 4 models that you can see in this list, how often they have been used. That means we have the tools. And I would like to mention that these models that we have here is microscale models. It's not mesoscale or macroscale models. So that means we have all these models, and we can calculate all the thermal indices, having the possibility of taking data of stations, but also taking data from simulations, from reanalysis data, but also from climate change simulations. That was the first part, and this was my methodology, and also providing the possibility what kind of models we have and how we can calculate them. And now I would like to show you some examples and the challenges that we have in terms of application of these thermal indices. I have selected 4 examples. The last example is a little more complicated, and therefore I will make it much shorter. And I would like to start with a popular event. There was a huge interest concerning the soccer games. I think most of us, especially we guys, are of course fans of any specific clubs, like Besiktas Istanbul or Bayern München and so on. And we start to think about that, what is interesting in order to quantify popular events. And who is affected? Is affected the athletes, is affected the organization, let me say the responsible people for the organization of them, or finally is affected the fans. And this can be run for several approaches. We have started 2014 and we run an analysis for the FIFA games who was planned in the summer 22 in Doha. And we made the analysis not for the athletes, but we made the analysis for the fans. And this example, I will show you the results in the next transparencies, went through the media. And it went through the media in all the world except Germany. And the headline for that was "Scientific Proof that a Summer World Cup in Doha is too hot for fans." Of course, it's an interesting topic, but it got more presence in the media and in public life in terms because it was first in the newspaper. We made a paper, we want to have a scientific approach and so on. What have we run in this context? You see here, this is the typical climate diagram where the FIFA has used in order to decide if the game, the time of the games during the year is appropriate to run them in Doha. Because they find out, they look, okay, 30, 35 centigrade, but they didn't think about this is the mean monthly temperature. Okay, precipitation is not a problem there. And this was the decision about the FIFA. What we have run was the following. We compare two different things. First, we compare the temperature, and then we compare the thermal index PET, as I mentioned before, the real field temperature, or the equivalent temperature called physiologically equivalent temperature. And then we analyzed always in the same classes that we have for thermal perception and heat stress and cold. We compare temperature and we compare also PET. And as you can see here, and in the diagrams, what you see here is the frequency diagrams separating the months based on an old climatological tradition. The old climatological tradition was to separate the months in 3 intervals, not in 1 interval per month. And we see that if you look on temperature, the temperature is rising up in somewhere about 40, 45. But if you look on temperature, then we have results where the physiological equivalent temperature is much higher than 50 and much higher than air temperature. This was in order to see which is the most specific time of the year in order when will be the best time in order the games can take place. And then we analyze also the diurnal pattern. And then we see that when we compare, you have here all the year and you have the different time of the day. We find out that during the day, especially during the time when the games have to take place up to after 7 or 8 o'clock in the evening and so on, is maybe not the most appropriate time in order to run the games. And there was a huge difference between temperature and also PET, because PET was much higher and so on. So we published, as mentioned before, these results. And then there was something like a controversy, and this controversy was between, let me say, the science side, but also about the organization of the local organization there. And we say it's not safe for players, also even for spectators. But the answer from the organization was we can cool everything. And our suggestion in the paper was transferred to the winter. The counter of them, as I mentioned, was we can cool everything. And some months later, the games have been transferred from, that was 2014, have been transferred from summer in the winter, and we got also diverse reactions and perception. But we have here a wonderful example, and where science can produce results which finally can be really applied. But it was not the communication aspect done by us, by the media and other people. After this paper in 2014, 2015, and then 2019, the World Athletics have been take place also in Doha, which was the first event that we had, which was an outdoor event in Doha. All the events, previous events have been indoor. And then we had, of course, we had huge problems. That was in September, October 29. And we had the collapse of several athletes. There was huge problems on that. And the reaction was that everyone is loser of the World Athletic Championships in Qatar. I have been there. I experienced also the hot conditions there. There have been around also measurements. And we had with the World Athletics a huge, an interesting meeting. We had also cooperation before. And the question was there, how will be Tokyo? That means the World Athletics realized, based on the conditions that have been published for the FIFA games, they realized that something has to be done. And then the Tokyo Olympics have been also analyzed in terms of bioclimate, mostly not only for heat, but also for the other parameters. And then one of the final decisions was, because the heat can be also a problem during summer, to transfer the outdoor activities like marathon and 50 kilometers walking, to transfer them to Sapporo. And some weeks ago, we have published also in preparation for the Olympics Games in Paris 2024, we summarized or applied the same method as we have applied for Tokyo and also for other locations for Paris, in order to provide a golden standard how that kind of studies can take place. This is a wonderful example that we have here, where science can really be helpful. And then I have a second example from Freiburg. This is something which we called bottom-up approach, because there was an instance situation. There was an open place in Freiburg. It's in the middle of Freiburg, surrounded by buildings of the university and the university library. It's a green area. And this green area, the municipality of Freiburg wants to transform, wants to make it different. And that was the result of the planners, to have there a pavement with sandstone plates, remove the trees and so on. And you can imagine that there was a revolution in Freiburg. There was a bottom-up approach here, that we have the people don't want that every week was something in the newspaper about it will be very strong heat there and so on. And there was also some suggestions, bringing the recent situation to the future situation, leaving the trees there. But the aim of the municipality was different. They want to have multifunctional space there. The place has been transformed. It's a very popular place now. And we have, in the beginning, run a specific analysis, and then we want to know what will be happen if we reduce only one tree there. And then we make also some measurements. We make also some simulations with the models that I showed you before. And then we focus only on one specific thing. Was the street. There was a bus station, and we analyzed the bus station very intensively. There was not the bus station we analyzed, but there was a tree close to the bus station. You see in the sky view factors diagram here in the middle of the tree, what will be happen when the tree will be removed, and the tree finally has been removed. And we find out that removing one tree, which will not be, was not so big, was about a diameter of 8 meter, about height 8 to 9 meter. And so we find out that the heat stress based on PET, which means strong and extreme heat, will be increased from 204 hours up to 330 hours. This is a lot. This is not 5 days. It's 3 times more, because we focus also, of course, during the day. But it was also a wonderful example. And I would like to mention that the same amount of trees that has been before on the place is still there. Some trees have disappeared, but that we have also new trees. The final result on that was that in my environmental pressure, that means bottom-up approach makes sense. We expect something in reality, but finally we get something different, because we want the place, some people want the place will be the same as it was before, but this cannot be happen and so on. And when we ask now the people, do you remember what have been in the past here? They very fast adapt in the new situation. And I can say that at the moment, finally, both sides are happy. And I would like to mention also that the story goes on, what about new materials, more artificial shading, and so on. This is also a wonderful example, providing numbers. This 125 hours per year increase of heat stress is not less, but this can be communicated. Another option that we have, especially in the agenda of each city everywhere in the world, is that the green and blue. I would like to focus on a very simple example on trees. During the heat wave of 2003, which was, let me say, maybe the most intensive heat wave in summer in Western Europe, we make a comparison for a specific location, and this location was what is the positive effect during heat of forests, because close to Munich, especially the federal state of Bavaria, they have forest climate stations, and they have instruments and measurements in outside of the forest, but also inside of the forest. And what we see here is the differences between outside and inside of the forest about temperature. So it's for the first 2 weeks in August. And if you see that, you see that the differences are not so high, maybe 2 centigrade, 3 centigrade. But if you focus on the equivalent temperature in this example, physiological equivalent temperature, we see that the difference between inside and outside is about more than 10 to 15 centigrade. And during the night, let me say, outside of the forest is more appropriate conditions and inside is not so appropriate. But during the day, inside of the forest, that means shade is one of the most specific factors that we have to focus in order to provide reduction possibilities about heat, especially in urban areas. And then I have the fourth example here, which is warning systems and action. That means measures must be taken. And I would like to mention that concerning heat, we have a very wonderful instrument. And this instrument has been produced, or these actions have been started in several projects and activities by the WHO and WMO, and these are the heat action plans. And these heat action plans have several success factors. That means several factors which we need. And if you look here, the factors that is included is mostly focused also on cities, but we need a heat health warning system. We need also the conditions indoors, which is number 3, but we need also urban planning and construction industry. That means all these results about green, about urban areas, how cities have to be constructed and so on. But we need also coordination, and we need also, let me say, education of the responsible people, but also information. And these heat action plans provide us really, let me say, give us this instrument in order to operate. And I would like to show you another application of a thermal index, which is not the same that I presented before, but it's a similar one. And it's this index called perceived temperature. We take here for the heat health warnings in Germany, we take the weather forecast, we analyze them in terms of an index with a similar model like PET. We get the perceived temperature. We include also the adaptation of people in the last 30 days concerning heat. Get for the administration level in Germany, which is counties, all this information. Calculate from the indoor situation heat in indoors with a model, and then we provide a warning proposal. This warning proposal is analyzed and approved by a biometeorologist. And then we provide the warning for the counties, and then we have several possibilities in order to provide them. But we have also, of course, we have smartphone applications, email newsletter for the authorities, but also for everyone. But we provide also information about elderly people, but also about the urban climate conditions. And this information all is communicated. That means we have here, in order to provide thresholds when we have extreme heat stress or strong heat stress, the combination of thermal indices with epidemiological data, long-term epidemiological data about daily data, epidemiology about 50 years, and then we can provide here, find out which are the thresholds. This was application of several possibilities we have here. And I mentioned before that we have here the possibility of models, and these models have some limitations. But when we want to run these models, we have to consider also the aim of the models. I mean, the models that we listened before. And there are also some summaries about, from my side, about the application and the curiosities about thermal indices estimation and application. But I would like to focus not only on the scientific level, but also on the heat management. Why? If I remember well, I mentioned this in the beginning of my presentation, that we have the climate change, but we have also urban climate, and there is a connection between them together. But we can focus on health, because health is one of the targets that is the biggest influence we will have in terms of health in the future. And we can concentrate on heat because we have several, how to say, strong knowledge about that, but we have also measures. And then we can focus on mitigation and adaptation. I see the adaptation more relevant, especially in urban areas, but also in actions that will be taken. And the actions that we can take is in the short term. That was the example that I showed you, the heat health warning system, where we include thermal indices, but also in long term, in terms of what is the effect of trees in urban areas. But we need also information, not only in a qualitative manner, but also in a quantitative manner. I think I'm coming to the end, but finally, 2 days ago, when I was preparing my presentation, I realized I have no present for Turkey. And therefore, I would like to focus on some results about Ankara. This is in the frame of the project managed by Andreas Santos Nuri from the Bilkent University. And at the moment, we are trying for Ankara to define thresholds for indoor and outdoor environments concerning heat. And I have here a simulation by regional climate models, which have been run from the Eurocortex data that we have. You see the same example that we had for Doha. We have on the left side temperature, on the right side we have PET, and you see, of course, differences in that, more than 10 centigrade, as I mentioned before. But when we look now on the climate scenarios that we have at the moment, we see again the historical situation. And when we look on the situation that we will have on the SCP scenario 4.5, we see, of course, there will be a change in the cold conditions, but we will have a change, a much stronger change in the heat conditions, which will be much more concerning temperature, as I showed in the previous graph. We will see not so much changes for the 4.5 scenario, but we will see increased changes, which will be maybe something like the double of the days of the year concerning heat for RCP 8.5. I mentioned before, very important is when we provide this kind of result is the communication. The communication has to be done in a very appropriate way, because here I have a graph. I remember that I have shown this graph some years ago in Erzurum. And this is a graph not presented from climate science, but this is a graph presented and produced by the planners. And they talk in reality about the same things, but they use maybe another terminology. That means we have to find a common language, because we talk about radiation, we talk about shade, we talk about wind, we talk about ventilation and so on. And the other way is that we have to reach the people who are affected, but also the authorities. That means we need a top-down approach and then a bottom-up approach. I have some statements. We have at the moment all these thermal indices. It's about 5, which are appropriate in order to run comprehensively. And they can be run by based on data on simulations. And these models are mostly microscale models. They provide important results. They provide good results. But we can focus also on the 2 parameters which has the biggest influence, which is wind and radiation. And we have to be careful when we are using models. We need validation. We have to consider the limitations, but also the possibilities of the models. And I'm always happy when people use models and send me questions and I have to answer. Then please read the manual because you didn't read the manual and so. Me personally, I leave one specific motto. You can read this motto here. Is from Nikos Kazantzakis, who said in one of his books, every human, we can see this philosophically, every human has his own circle composed of trees, animals, humans, ideas. And if he don't, he say this circle, he cannot be saved. Thank you very much.
Thank you very much, Professor Matzarakis. And if you have any question, dear participants, we can ask one or two questions. Then we will proceed with our next speaker. Yes. Osman Hocam, please ask your question.
Hocam, thank you. In fact, I didn't want to ask a question. I just applaud this nice presentation. It was a very nice and excellent presentation. But as you give me the opportunity to ask a question, maybe a simple question, Andreas. Thank you very much for the presentation. It was really, really nice. And you also underlined the fact that even a single tree can make a difference in city space. And based on that research, I mean, I'm wondering if the type of the tree, the age, and these sort of criteria, is it important, or does it make any difference with the addressing of heat stress? Because you mentioned that even one single tree is important.
Yes, Osman, thank you very much for the question. I need about 30 minutes to explain that. But I will be very shortly, of course. Yes, the endophycal factors, nutrition, play a role. Yeah, and this is right. But in order to be short, we have to focus on the experience that we have on the regional trees, which are relevant, which are stable. This is the one point. The other point is we have to be careful. And I'm happy that in the last IPCC report, for first time, the term maladaptation is standing. Is focused on that. And in order to say that we see wonderful possibilities providing in cities about trees, we have run this analysis maybe 6 months ago. How long should a tree live in order to provide appropriate shade? This is after 15 to 20 years. That means we have to focus locally. And one strategy that we have from Freiburg, we cannot transfer this to Erzurum or to Ankara. This is very important, and I think here we have to be very careful. But the other factors, as you mentioned, like robust trees and so on, we need, but it has to be the appropriate trees. And we have to look also on other factors, which is about drought. It has to be about air pollution, emission of volatile organic components and so on. Yes, it's important, and we have to bring this together. Otherwise, we're running to maladaptation. You're right, but we have to be careful. But first of all, in order for communication, I think it's okay, and it's enough to say, if you put trees here, you will reduce the thermal perception of the people in temperature 2, but in terms of what the people feel, more than 10. I think this we have to communicate. Thank you for your question.
Yes, thank you very much for your presentation and speech, Professor Matzarakis. So we are proceeding to our keynote speech with Abdullah Kahraman, with the topic of impact of anthropogenic climate change on severe convective weather in Europe based on convection permitting simulations. Yes, Dr. Kahraman, the floor is yours.
Thank you. Can you see the presentation?
Not now. Yes, it's okay.
Okay, so my name is Abdullah Kahraman. To introduce very briefly myself, I'm a purely meteorologist, nothing with biometeorology or bioclimatology, to make sure that I am somehow from a different field from most of the people attending in the conference. So what I will talk about today is about these changes in the convective weather, severe convective weather in Europe, based on very high resolution simulations. Of course, I will try to define the technical concepts first to proceed. So I'm affiliated with Newcastle University, but I'm spending my time in the UK Met Office Hadley Center, which is the climate center of UK, for the last 3 years. And before that, I was in Turkey as a meteorology forecaster for like almost 20 years in the Met Service, and then in Samsun Meteorology Department as assistant professor of meteorology. Anyway, so today I will be speaking about, as I said, these simulations. And to start with, I will come with the extreme weather and the climate change issue. So the climate change for a common person in the public is being understood in terms of the more frequent or more intense occurrence of the extreme weather events and extreme climate events. So is this true or not? The first time the IPCC report has included a dedicated chapter for the extreme weather events and their change with regard to the climate. And what we know about extreme weather with the climate change is not actually exactly the same as how the public is anticipating from this concept. What we know is that, looking at this very simple graph, what we know is that usually the extreme heat and extreme cold events are very well understood in terms of relationship with the climate change. And we can easily also attribute these kind of events to the climate change when compared to other types of extremes. Because the more the temperature is increasing globally, we see more intense and more frequent heat waves. And also we can see less frequent and less intense cold waves. So this is very well understood and very well represented in the climate models. So we are very, very confident on this effect of climate change in terms of globally and also the regional changes. We can definitely say that we are almost sure on these changes in terms of extremes. But when it comes to other kinds of extremes, it's a bit different. For example, about the droughts. What we know about the droughts is that the Mediterranean area and also these maybe Southwestern America or some parts of the globe is experiencing some kind of drought because of the climate change. But we are not as confident as the increase in the heat extremes, for example. It's a bit more different and more complicated issue. And about the extreme rainfall, again, we know that globally there will be more short duration precipitation extremes, short duration rainfall extremes or extreme rainfall, a bit more frequent and more intense than that. But when it comes to other things, it's a bit more in the grayish area, like tropical cyclones. The frequency is found to be not changing much, but the intensity of some of the tropical cyclones is really increasing. But this is a bit more uncertain. Extreme snow and ice, as we saw in March in this year in Turkey, there was extra more winter conditions when compared to previous decades and years. So this is, of course, showing some regional variability of the climate, but still uncertain with respect to climate change. About the extratropical cyclones, which are the mid-latitude cyclones, which we can define as 2/3 of the rainfall falling on the mid-latitudes, like Europe, North America, or Turkey, is experiencing this rainfall from these cyclones. And what we know about these frequency of these and intensity and the area and the movement speed, etc., these kind of things are still uncertain how they will be changing with the climate change. There are many studies on this, but still the conclusion is not as strong as we know about these temperature extremes. And about the wildfires, again, there is some uncertainty. And the bottom of this graph, what we see is the severe convective storms, which is the main subject that I'm working on for many years now as a meteorologist. And now I'm trying to apply these approaches to climate science to see how these are occurring and how these are changing with respect to climate. So what are the severe convective storms? These are actually what we know that the storms, thunderstorm clouds, which are producing tornadoes, which are producing large hail or very large hail, which are producing locally damaging winds, which are very strong, and also some excessive precipitation and rainfall events, as well as lightning. So when these storms occur in the current climate, in the current real-time weather, as a real-time weather, we can somehow forecast it in a more broad way, not exact location, exact timing, but we can give a probability of it in the upcoming days, if they will be happening or not in a broad region. We cannot say the exact location because they are very local. We cannot say the exact timing because it's not possible to directly perfectly simulate within the weather forecast models, but still we can somehow forecast in a few days range. But in the climate context, it's much harder. So what is the reason? The reason is actually the scales. This is some kind of very usual satellite image. What we can see is the left-hand side, there is some kind of cirrus clouds, which are more transparent and more harmless. And the right-hand side, you can see some cellular clouds here, which are the convective clouds. Some are nice weather, fair weather cumulus, some are a bit more deep, so can become to thunderstorms like these here in the Eastern Mama region. So, but what you can really see is that the scale of these clouds, these convective clouds, is really very small when compared to other features of the weather. These can be as small as less than 1 kilometer in size, or they can be a bit more than maybe 10 kilometers somewhere if they're well developed, maybe much larger. But still, we need to use very high resolution models to resolve these type of clouds and the hazardous phenomena like tornadoes, like hail, like other things, which are produced by this kind of smaller scale clouds. So thinking about the global climate models that we use right now to make projections of the upcoming century, it's typically like 25, maybe 50 kilometers grid intervals. Now, the best ones, let's say. So these climate models are not really able to capture or simulate most of these features directly. What we do is that they are somehow pretending to simulate it, which we call as parameterization schemes. These are being implemented within the model with some kind of more basic assumptions, and the results of these things in terms of temperature change, precipitation production, and some other features of fluxes, etc. These are implemented in the model a bit more, how to say, empirical ways. So this is not the good way actually to find out how these extremes will be changing. So the biggest uncertainty here is coming from the model capabilities and other things. So what to do? The best thing to do can be using very high resolution models, which are resolving these, as we use now for weather forecasting in the short range, a few days for weather forecasting, for all the climate time scales, like decades or century. So, of course, the biggest problem here is the money, because the computational cost making these simulations for so long, for 10 years, 20 years, is really very expensive. So we need billions of dollars of funding for these computers to run these models in a very good resolution to resolve these kind of convection events. So this is what Met Office is doing here. We have UK climate projections, which is covering entire Europe continent with 2.2 kilometer grid spacing. So we can resolve very big amount of this type of convection and this kind of processes within our model. In the upper side here, you can see that these features, small scale precipitation features, are being resolved this kind of model, while in the global model outlook, you can just see a patch, just to see a curtain of rainfall, which are less realistic. So this is what we can resolve with this very high performance models are producing. So here, with the simulation suite, we have 10 years of data for the current climate and 10 years of data for the future climate, which is under RCP 8.5, which is somehow business as usual scenario for, let me say, bad conditions. And of course, we also have 20 years of hindsight data. So we have pretty good resolution simulations for 1 decade for the future and 1 decade for the present climate, and we can compare these simulations to see what's happening if the anthropogenic climate change is occurring in a bad way, let's say. So these models, we can, for example, see the London as this with a 12-kilometer grid, while we can really see much more details of the topography, of the urban effects and other things with such a high resolution model. So it's able to really capture much more different features of these, especially smaller scale, but extreme weather events and processes. So one of the output from this study is the impact of climate change on extreme rainstorms. So what we have been doing on this is using an ingredients-based approach on these things. This is an approach which is used by severe weather forecasters in real time to forecast the real-time weather. But actually, the reason I came here to the Met Office is applying the severe weather forecasting approach to the climate model output to see what's happening in the future climates in average and what it is compared to today's climate in terms of this. So this model with very high resolution gives us the ability to apply a bit more realistic approach for this kind of events to occur. One of the papers published on this issue is last year. It's called Stationary Intense Rainstorms Spreading Across Europe under Climate Change. So the motivation was looking at the precipitation extremes, short duration precipitation extremes, because what we know is that they are increasing because of the warming and more evaporation and more water vapor in the atmosphere. We know that they are already increasing in the observations and the future simulations. But what we want to look at this in a more like a severe weather forecasters way. So we want to cover the most broad approach to look at this. So this is why we are looking at the potential reasonings and other aspects of these extreme rainstorms. So looking at the ingredients, actually this study was really very well covered by the media in the last year because of these flooding events in the Central Europe. So looking at the ingredients for heavy rain is a very, very simple concept by Chuck Doswell, a well-known concept. The amount of rainfall falling down in one place for one time is a product of average rainfall rate times duration. So what we need, if we want to increase the amount of rainfall in one place to make a flash flood, we need to increase average rainfall rate or duration or both of them. So to maximize the average rainfall rate, what we need to do is to maximize the amount of moisture in the atmosphere, which is represented here as Q, or the condensation rate, because the water vapor needs to condense into liquid water or ice crystals to fall down as precipitation. So we have to see how fast it is condensing. And we use this vertical velocity because the water vapor is actually getting up in the atmosphere, and with these upwards motion, it's getting condensed. And also the precipitation efficiency, because not all the water, condensed water, is falling down as precipitation. Most of them is maybe evaporating. So we need to also take into account the efficiency of the system to produce, to convert this amount of liquid water into precipitation or rainfall. So this is a product of these three factors. On the other hand, the duration is depending on many things, and it's actually very, very hard to analyze because the movement of the storm system is important, the size of the storm system is important, also the shape of the storm system is important, so many things, and the lifetime of the storm system, how organized it is, it's half an hour or 2 hours or 5 hours, whatever. So this duration thing is very, very complicated, and in this study, we only focused on the slow-moving storms rather than other aspects of the duration. So what we handle is this amount of moisture, amount of condensation via vertical velocity, and slow movement of the storm systems. We still neglect the precipitation efficiency, which is also uncertain, but we also, of course, take some parameters to somehow estimate the effects on it. So these are the basic results. What we see in the top is the frequency of the extreme precipitation potential. How we define the extreme precipitation potential is this a metric that we have created to look for these kind of environments, is that it's a combination of high humidity, high moisture. So this is a very high threshold for that level in the atmosphere. So we are looking very, very moist atmospheres or very moist weather, looking on these things. And we are also trying to make sure there is some kind of storm point exceeding happening over thing. This is not a very high threshold, but still it makes sure this is some kind of storm clouds occurring there. So with the combination, what we see is that in the current climate in the Europe, we can actually in the summer times over the continental areas and in the autumn in the Mediterranean zone, we see these kind of things are occurring likely 24 times per 10,000 square kilometers over typical European area. But in the future climate, we can see that this is increasing 7 times. So we see 7 times more environments such as these, which are likely to produce some kind of heavy precipitation storms. So this is what we see. It's like 7 times. And most of the increases occur actually over the Mediterranean area and the coastal areas in the south. And when we come to SEPP, which is the slow-moving extreme precipitation potential, we are adding one other parameter here, which is the coordinate vector magnitude. It's very technical, but I can say that this is some estimation of the storm system movement. So we are trying to take into account very, very slow storms, which are almost stationary on one city, on one point, which is less than 3 meters per second speed. So this is a very small subset of the EPPs, like a few percent, you can say. So in the current climate, Europe is unaware of such storms because usually this storm occurs and just it's pass over your city. You are experiencing something like 10 minutes of very intense rain. Maybe it's flooding elsewhere or somewhere else, but still not as perfect storm as you can see very rarely over the Mediterranean Sea in the current climate. So in the future, the biggest change is actually occurring in such storms because not only we see an increase in the amount of moisture and vertical velocity, whatever, we also see that the speeds of the storm systems are decreasing. So they are moving much more slowly. And these almost stationary storms, which are building up over your city and spending all entire lifetime, half an hour, maybe 1 hour, maybe more than that, over your city and just falling down all the rainfall over your city. So this is extremely having the potential to produce a flash flood event, which is due to this kind of convective storms. And this type of storms increasing like 11 times over our domain. And the worst thing is that this is happening in entire European continental areas or land areas. So this is what we see a very rare Mediterranean phenomena is occurring now over all land areas in the Europe in the future climate with 11 times more degrees. And the worst is happening more, increases more in the land areas when compared to sea areas. It's something like 14 times over the land areas when compared to sea areas. So the future SEPPs are much more focused on the land areas. This is one of the differences. So what we do is compare this with other analyzers, independent analysis from the model results, using some kind of tracking technique. We are tracking the MCSs which are producing such kind of things, and in the model output verifies very well the slower movement of the storm systems in the future, and also the increase, a huge increase in the rainfall that they produce. So this is some kind of verification done with tracking analysis. I will not really go deep into these things because of time restrictions, but the most of the increase is coming from the moisture increases rather than other factors. The vertical velocity increase is somehow contributing in the summer, and the slower storm movement is very correlated with the high level winds in the atmosphere, which we call as jets. So the slowing of the jet via Arctic amplification, what we call, is probably resulting in the slower movement of these storm systems. Yeah, the slower systems are more likely to producing much higher precipitation as we see. The very, very extreme amounts of rainfall are exclusively produced by very slow-moving storms, both in the current and the future climate data. And this is the relative humidity in the mid-troposphere, which is some kind of contracting this fact, which we are tracking for precipitation efficiency. And this is how it goes. So, as a result, we see more frequent extreme rainstorms across Europe, and the largest contribution comes from the increasing moisture, and the slowing down effect is actually resulting more in problems over the land areas. One other sample study is about the lightning. We need three ingredients for deep moist convection. One is the instability, the moisture, and the lift. And electrification in thunderstorms is actually usually produced by these mid-level parts of the clouds. We see that there is some ice crystal moving upward with upward motion and some groupal or larger ice particles falling down. And when they just bump into each other within this range, because there are also super cooled water droplets here, they are somehow charging. And because the small particles is going upwards with the upward speeds, and the larger particles are suspended in the mid or low levels or maybe falling down as groupal, we see that bottom of the cloud is usually negatively charged and the top of the cloud is more positively charged, so that we see this distribution eventually resulting in lightning and the charging effect. So this concept, this electrification concept, is not really very well applied to lightning projections in climate before, but in the recent years, there is some change on this. Like 8 years ago, there was a paper published in Science by Roms that showing that the Cape, the energy, the storm, forest storms, and the rainfall is increasing with climate change. So there will be something like 12% more increase in lightning in the future. One other study in Europe said that no, that's not true, because when we apply this a bit more developed ice flux approach, we see that in the tropical regions, there is some decrease in lightning because the amount of ice is decreasing within the clouds due to warming. So this is not exactly true. In some parts, mid latitudes, high latitudes, yes, the lightning can increase, but in some other parts, it can decrease when compared to more conventional techniques. So one other paper just 2 years ago published made some comparison with these new approach and the old approach. And so that it's really still uncertain to look at these things. And one new paper, which is published last year for only a small part of Germany, showed that these new techniques, which are taking into account these ice flux or global flux, are really much better representing the truth, the observations, while the older techniques are really not showing us the good thing. So the way the climate change is affecting the lightning is really very uncertain, and it's much better to use new techniques rather than the older techniques. And actually, these old techniques are not really older than 10 years, so this is also new, but still there is a very big improvement in terms of representing lightning in the climate models in the recent years. And what we do in the Newcastle and the Met Office is use this Met Office unified model lightning parameterization, which is taking into account this global and ice fluxes and the changes in this in the future and current climates. We also compare the European simulation with 12 realizations of the UK simulation, because we also have this very high resolution simulation only for the UK for 12 years, while we have all for Europe. And our simulation is ranging between these 12 different realizations of the future climate. So this is somehow an acceptable way of looking at the simulation to see how the lightning is changing, and we can anticipate what other uncertainties are. So the current conditions here, this is a very well representation of the current climate, lightning climate of Europe, like the summertime over the land and the autumn or the Mediterranean areas. And what we see in the future climate is changes in the future is like this. So we see blue colors and red colors. So in some locations, there is some decrease in the lightning, while in actually, especially Southern Europe with higher elevation locations, and in the northern areas like Scandinavian lands or some parts of UK, we see an increase in lightning. So the lightning problem is not directly easy to understand or resolve with the models, but there are some regional and seasonal differences in terms of lightning. And we also look what is the reasoning behind this, like increase in the thunderstorms, but also increase in the melting level height, which is changing the amount of liquid and frozen water and ice crystal droplets within the clouds. So this is a counter effect. So the increase in the thunderstorms, but the decrease in the cloud ice within the thunderstorms, leading to a more complicated picture of lightning changes in the Europe. When it comes to hail, we are looking for severe hail environments and also the realization of the hail within the model output. So this is the picture of generally severe thunderstorm climatology of Europe with the model output. We also use some different proxies that cannot be used with the previous conventional low resolution climate models like updraft helicity. So we can see how their densities are changing, which are mostly responsible for very large hail stuff. And we also can compare these and come up with some kind of different new parameters for tracking hail with these very high resolution models. Like we see some case studies over here in Germany with like very large hail storms, and eventually create some hail climatology with the data that we have using this model output and some techniques that we developed. So here we see that most of the hail is occurring in the summertime, as we observe in the real life, and in the autumn over the sea areas. So in the winter, it's really very rare, except in some parts of Mediterranean coasts. Of course, the hail observations are not also perfect. So that's why it's really very hard to verify this with the observations, because most of them are locally occurring stuff, and it's really very hard to track every hailstorm that's occurring if there is no damage on the ground or it is not being reported. So with these under-reporting issues in mind, we are trying to also compare these results with some kind of satellite observations, which are somehow, again, not perfect, but some estimation of hail distributions. And this is giving one of the best results in terms of other climate studies looking at the hail problem. So comparing the proxies, we still see that there's an agreement. And for the future changes, actually, it's a bit more complicated. There seems to be some kind of decrease because of melting level height increases, but also the largest hailstones might be not affecting from these things because they are less likely to be getting melted with a very fast terminal velocity from the underground. So it's a very, very gray and very uncertain aspect of climate change. So what we see is that this is a new era in climate change science with very high resolution models with the CPMs. And we have now more realistic simulations capturing extremes much better. We now have better understanding of hazards with ingredients-based approach applied to these climate models. And some sample results with RCP 8.5, we see large increase in flash flood producing storms in Europe, and lightning changes in Europe variable locally and seasonally. And severe hail potential in Europe is still uncertain. And we need to have more work, preferably with ensemble, with plenty of models, different approach to look for how the climate is changing and extremes in the Europe. Thank you very much for listening to me.
Yes, thank you very much, Dr. Kahraman, for your valuable presentation. We have some time and we have two questions. If you allow me, I can ask these questions because they wrote the chat part. So one question is, how is the effect changing climate variability to future climate projection of forecast power? Yasemin Balka asked this question. Please, can you explain the question maybe in Turkish? Or Dr. Kahraman, if you understand, you can answer, but I didn't understand this question. Therefore, I want the question. I want Yasemin to explain her question. Or
is this power? Yeah.
Merhaba hocam.
Merhaba Yasemin. Merhaba. Türkçe sorarsan ben İngilizce de çevirebilirim.
Türkçe olarak sormak istiyorum. Şunu da sorabilirim ama daha izah etmek açısından, yani hani biz iklimin değişkenliğinin de değiştiğinden bahsediyoruz. Dolayısıyla bu iklim değişkenliğinin değişmesi bizim yaptığımız iklim projeksiyonlarının tahmin gücünü nasıl etkiliyor? Yani hani tutarlılık açısından ne gibi bir değişikliğe yol açıyor? Ben bunu merak ettim aslında. Teşekkür ederim.
Teşekkür ederim. Yasemin asked the changing in climate, how can the change in climate affect the forecast, yes, weather forecast, as far as I understand. Yeah. Yes, Dr. Kahraman, please.
Actually, I couldn't really get the beginning of the question because there was, I think, a problem with sound. But as far as I understood, it's about the climate variability and change and how this happens in terms of weather forecasting. Actually, the weather forecasting problem is a bit easier problem when it comes to climate issues, because if we have really good models which are representing the ground truth well in terms of observations and good data estimation and good approach to resolve them, we can do good forecasts on them. And in the future climates, in any realization of the climate, we can also run these models and do weather forecast. So I don't think that the weather forecasting will be really badly affected with the climate change. In this retrospect, it will be much better with the improvements in science, improvements in the models, in the computers, in the observations and everything. So I believe this is not really a very big issue in there.
Yes, thank you very much. Another valuable question comes from Dr. Cenk Demiroğlu. Is there a relationship between the ongoing extreme heat in the poles and the persistently cold and snowy March in Turkey? If there is, would such extreme polar conditions still lead to similar opposite weather patterns in Turkey in the future? The question is that, Dr. Kahraman.
Yes, actually, yes, there is a relationship between these things because when the Arctic is getting much warmer, usually the cold air masses are spreading across lower latitudes, like happened this year. So there's a direct relationship with this. But of course, when looking at locally, we cannot really attribute everything exactly to the climate change issues or everything, because there should be some kind of dedicated study, attribution study, to show that any weather event or some variability in the climate can be attributed to the climate change. So in terms of climate change question, this can be thought as in the future times, maybe there will be a bit more different variations in the Arctic oscillation and so the polar vortex and other things. But this is still subject to some specific study doing on these things.
Thank you very much again for your presentation and for your answers. So if there is no question, we can proceed with the next and the last speaker of this session. So the VISVALDAS, VARŽINSKAS. If I have wrong pronunciation, please forgive me, VISVALDAS. Sustainable food packaging trends, natural fibers application. In single-use packaging. Yes, floor is yours, VISVALDAS, Dr. VISVALDAS VARŽINSKAS. Thank you very much.
Hello, dear colleagues, dear participants of the conference. I'm very happy to participate here with you, and I'm very thankful for invitation to cooperate. I will try to share my slides now, and I will try to go into presentation mode.
Yes, we can see it.
So I hope that now you can see slides well. Yes?
Yes, it is, we can see it.
You can see slides.
Yes.
Perfect. So let me start then. As I mentioned previously, I'm very happy to participate in your conference, and I would like to share with the results of ongoing research at Kaunas University of Technology in Lithuania. And my presentation is not directly about the climate change, as conference is dedicated to bioclimate change symposium, but I'm not going to speak directly about mitigation or adaptation to climate change, but I want to touch some questions about the indirect aspects of climate change, such as the daily use of non-renewable resources and the trends leading to the use of bio-based materials. Okay, so I am representing Kaunas University of Technology, where I am associate professor at Institute of Environmental Engineering, and also I'm leading the Center for Packaging Research and Innovations. Our research center has almost 5 decades of experience in research, creation, and installation of automated packaging machinery, mainly used for food industry, creation of prototypes, their production, comprehensive test and improvement has always been an integral part which allowed creating of new equipment which complies fully with formal requirements applied by both industry and various regulations. Recently, issues related to legal regulations, sustainable development, and environmental impact of packages and packaging processes become more and more significant for the center's activities. My personal background, I'm chemist, I'm a master in chemical engineering, and then I've got a PhD on environmental engineering. So my knowledge in environmental engineering and the research field of product eco-design, life cycle assessment, cleaner production, currently is very valuable now in the research on packaging, because the packaging nowadays is very much driven on environmental issues, which are also very much related to the climate change. Actually, the need of research and the context of what we are doing very much related with the situation which is happening now in Europe, in European Union, and all over the world. In European Union, and each year we generate more than 2.5 billion tons of waste. Smaller part of it, up to 40% is recycled. Around 40%, less than 40% landfill, and 23% incinerated. It means then that more than a half of materials is lost. The value of materials is lost, and it is about half of billion tons per year. And this topic became more and more challenging and important during nowadays. During the COVID lockdown, the world lockdown, the world supply chains of resources collapsed. Also, due to geopolitical situation, there is a huge rise of the price of natural resources and fossil fuels. And it really drives industry to check the options, how to save the value of materials in the life cycle, and to have the value of material as much as possible for the longer period, not to take it, consume, and lose by landfilling or incineration. And among the amount of materials which really can be potentially taken back, the packaging materials consist in a large scale, because usually the packaging materials are consumed mostly single use consumption, as also we're taking the goods into our houses from the shop, and we're taking out of the packaging, and packaging becomes waste. Yearly, we have in more than 256 million tons of paper production, around 140 million of plastic production, and the trends are showing that the plastic waste is growing up. In 2018, the amount even went up more than 15%. And this number is growing, especially due to COVID period, when we used a lot of single-use packaging, paper and plastic. And also the logistics and the internet shopping raised cardboard consumption very significantly. And around 40% of packaging is single or very short use. And in many cases, it's food packaging, which ends up in incinerators, landfills, or leaks into the environment. And in the discussions with the industry, with the producers of products, we're asking what are the main drivers for packaging development nowadays? What are the main conditions which really defines why the packaging in the shopping malls, in the market is like we see them? So there are there are three main drivers. First of all, the materials availability and the price of them, and industrial process, how we can pack. So in automotive packaging, if the company owns the huge packaging line equipment, so it's not easy to change the different materials, because usually equipment is produced to do the packaging process in some particular material and so on. So changing of materials needs investments, and also the price of materials is very important. But this driver is very much under the pressure of another driver. So it's legal requirements and standards, which are coming more and more strict, especially regarding the packaging waste and pollution of environment with the packaging waste. And definitely one of the most important is consumer needs and market trends. So environmental awareness and the care about the climate change, about the global changes which are happening nowadays, really drives the market and consumers into another opinion. So consumers, especially in European Union nowadays, are ready to pay more for more environmental friendly option, and it really affects the market. So the customer needs and market trends is probably the major driver nowadays. Speaking about the packaging, it's very important to understand that the packaging by itself, it's not the primary packaging which we usually can see and take it in the shopping malls, in the shops, because if we have a product which is packed and in the shop, we're taking it and putting it in our shopping bag. This packaging is wrapped in secondary group packaging and tertiary transport packaging, and to take the product safely from the production site to the consumer shopping bag, usually we need quite more packaging materials than we can see in the shopping mall, where we are taking the product with the primary packaging. So if we will see the amount of total packaging, primary, secondary, tertiary, so we can see that this is quite a significant load of different materials which becoming waste. So and the tension on the material, the price of materials, the lack of some of materials, and the price of packaging waste management gave the first tendency for the research, which we're doing very intensively. So companies are trying to find the optimum packaging design. What does it mean? The major and the first mission of packaging is to provide security for product, to securely to take product from the production to the consumer. So safety of product is the major function, and to achieve safety, we need to use some amount of materials. If we will use not enough of packaging materials, so then we will lose some products. We will break or make products not useful at all, and we will have under packaging. If we will raise the amount of packaging materials, then we will achieve some optimum pack design point. And if we grow up again packaging materials, the function will not change, but only the environmental impact and the price and the value of packaging will go up. So this is the optimum pack design point or dot with a minimum material, but the maximum efficiency is the topic which is very much required by the producers. And that's why we are doing a lot of tests and doing projects on packaging systems in order to provide the particular information for the producers, how to select the set of packaging materials and not to waste a lot. why this optimal material amount is needed. Of course, the huge pressure comes from legal requirements. And one of the major requirements, I guess, is packaging extended producer's responsibility. So it's the principle which tells that polluter pays for the treatment of the waste. This extended producer's responsibility in the beginning of 2000s, there was only in the European Union, but nowadays it covers bigger part of the world. What does it mean? It means that if a producer releases product with packaging, so producer is responsible to pay for the management treatment of the packaging waste, which is released into the market by the producer. And this extended producer's responsibility is also working for electronic equipment, for pharmacy, medicine, for tires, scrap tires, and other products also. So when the producer is responsible and paying for the treatment of packaging waste, so definitely producer is thinking how to release less material into the market. Also, one significant directive in the European Union was Single-Use Plastic Directive, which was released in 2019. And this year, in 2021, 10 different products were banned from European market. Cotton butt sticks, cutlery plates, straws, sticks for balloons, expanded polystyrene cups, expanded polystyrene food containers, expanded polystyrene beverage containers, and all products made of oxo-degradable plastic, which are making the pollution with microplastics. And this directive gives quite big tension on PET bottle producers to reduce the amount of PET, to use recycled PET, and recycling goals are coming. So member countries really thinking how to implement the strong legal requirements for the single-use plastic products. Shortly about the pressure from legal requirements, but the main and the most interesting thing is how packaging is changing due to the market trends, how consumers with a better and bigger environmental awareness are affecting the change of packaging. And 15, 20 years ago, we had the communication via TV, newspapers, and some commercials via radios. And nowadays, when we live in the age of social media, when everyone who owns the camera is able to create the personal flow of information and in the local social bubble transfer the messages and make marketing and share the videos or pictures. So we have a flow of different pictures which are changing the view of us as consumers. I have a couple of pictures for you to show what is nowadays in the social media. And day by day, when people are seeing these pictures, they're changing their mind. Pictures without comments. Not much to say, and these pictures really tells a lot. Some of them are together with labels of some producers. I guess this one is very famous picture, which is really illustrates the situation in oceans. And of course, we have the consequences, which also gives us some message. So, and definitely industry reacts and industry makes changes and gives a trends for the research. One of examples, colleague from Edinburgh University understands that the huge pollution of plastic single-use PET bottles is in the oceans, developed material which can disappear in the sea environment, in the salt water with microorganisms in 2 weeks. So this bottle in 2 weeks disappears and becomes the part of sea ecosystem. Also, a number of pictures which we see in the media is related with six-pack rings. So the plastic rings, when they are entering the environment, they're very dangerous for animals and then different species. And companies are starting to react when people see some emerging pictures and the awareness rise. So one producer from United States, the saltwater brewery, produced six-pack ring and used hop waste from the beer production, and this six-pack ring becomes a food for fishes and sea animals when it enters the sea. So instead of polluting, they even feeding the sea fishes and animals. Of course, the topic less is more is very relevant, and for some products, the refilling system is used more and more when we are buying some product which consists a lot of water. So water we have in a tap at our home. So maybe we can take only a small bottle of concentrated material and fill the water at home. And we don't need to produce and to take from factory around the world and then sell the huge amount of product where the water consists up to 60–70%. One of the trends is the paper versus plastic. So when people see that there are huge amounts of plastic in the oceans, in the landfills, so the plastic became the bad material, and there is a trend to produce as much as possible everything out of paper and to change the plastic packaging. In some cases, it works. Molded paper litter jug, which is also made not from plastic, from paper. It's quite good, but also there are some funny examples like development of paper bottle. The producers of different manufacturers of different beverages started the race who will produce the paper bottle, and one company from Denmark announced that they are going to produce the first paper bottle for beer, and we were waiting for the solution, but unfortunately in 2020 they proposed the option, the paper but the plastic inside. So they have the PET inner, and it's combined plastic which is suitable to incineration or landfill. Other producers also proposed the plastic paper bottle option to the market, but the 57% of paper, 43% of plastic, so it's nothing about the sustainability. And the packaging developers, Paboko, they produced the prototype also for Coca-Cola company, but with the plastic elements, unfortunately. And in the market, you can even find some very funny examples, like you see in the picture from the newspaper, where you have the hello and paper bottle, but the plastic is inside. So it's nothing about greenwashing and possibility to trick consumers. And at this point, there are examples of good solutions which are based on a circular economy of possibilities to consume the local waste. And the producers of sparkling wine, they produced the packaging for the bottle from the grape skins. So from the grape skins, they produced cardboard, which is biodegradable and recyclable, and they used their waste and implemented the circular economy concept and produced the option. And at this point, I would, moving out of from the trends in the industry, I would like to switch on our research areas, which also are driven by what is going on in the market, because our research center is very much related with industrial companies. We are reacting what is happening. And at this point, we found the niche and the field for research to develop the concept of compostable packaging. And the potential for compostable packaging is based on the data which we can get. Most of the research conducted on plant origin feedstock application in food packaging and other sectors highlights the importance that this feedstock is renewable and demonstrates low environmental footprint, especially if waste or byproducts are used. At the same time, researchers note the importance of life cycle assessment, as not only raw material stage, but also end of life plays a significant role in food packaging life cycle. If we live in European Union, so in each citizen of EU in 2018 generated a huge amount of packaging waste, paper packaging, plastic. And we see that the recyclability rates are quite high for paper packaging or plastic packaging, but we still have a huge potential of food waste, which is a bio-origin resource for bio-based and biodegradable plastic. Definitely, there is a conflict. If we want to create a biodegradable plastic, we need to use biomaterials, which we need to grow. That means we use soil and resources, but still we have a food waste flow, which is around 50 million tons per year. Non-recyclable plant origin packaging, for example, food packaging contained with the food leftovers and grease oils, if designed to be a compostable, brings benefit into circular economy by taking a significant part in cleaning waste streams and supporting biological cycles. Bio-based polymer market is still in early development stage. German Nova Institute reported last year that bio-based polymer market share was less than 1% in global plastic production, which is 2.41 million tons. Bioplastic market is expected to triple by 2026, reaching approximately 7.6 million tons. And speaking about the bioplastic, we should define the three main groups. So we have bio-based and biodegradable plastics, like polylactic acid, PHA, starch blends, and so on. Then we can create biodegradable plastics from fossil-based materials, and we can create non-biodegradable classical plastics from bio-based materials. And this group, the term bioplastics is often used for a group of different materials. Materials based on biomass, materials that are biodegradable, or a combination of both. And for example, there are also fossil-based biodegradable materials and also bio-based materials that are not biodegradable. And bio-based plastics can also occur in blends or in multi-layer structures with fossil-based plastics. Therefore, we use the term bio-based plastics, as can be seen in the figure in the slide. A lot of different types of resources can be used to produce a lot of different types of bio-based plastics. So from oils, from sugars, from cellulose, we can develop polyethylene, polypropylene, PAT, PLA, PHA, and different as biodegradable plastics as the regular polyolefins, which we can recycle as many times as we want. Bioplastics currently represents still less than 1% of the more than 367 million tons of plastic produced annually. However, contrary to a slight decrease in the overall global plastic production, the market for bioplastics has continuously grown. And this is the assumptions about the future growth of bioplastic market till the 2026. So for what purpose is the best to use the bioplastics? And at this field, we found a niche of compostable food packaging. The major task of food packaging, first of all, protection, physical protection, barrier properties, information for the consumer and promotion of product. And added value to use biodegradable and compostable materials for the food packaging is a solution for non-renewable, alternative for non-renewable packaging, simplified consumers experience, cleaner recycling systems, compost support soils as carbon sink, and fiber-based compostable packaging can serve as the valuable source of carbon and composting process. What is the best fit? And truly the priority for packaging is to recycle. And in many cases, in many products, we should use where we are using plastic in order to have the best options for keeping the product. We should collect and recycle. But in some cases, we have non-recyclable plastic, which is usually condemned with the waste. And if we will take the flow of flexible packaging or food packaging, we see that we have some of packaging which is with a wet food residue, with the food scraps, moist, sticky, gooey, oily residue. And then we have the packaging which is not anymore suitable for recycling. And at this point, if we could use biodegradable packaging with the food products, which really reduces possibility to recycle plastic, we could put the packaging together with food leftovers in the composting, and then we don't need to have separate selection system for bioplastic, and we can compost them in industrial or municipal composting facilities, as also the single-use plates or cups also can go together with separately selected food waste and can become nutrients. And it gives us assumption of what kind of products and what kind of food products has the biggest potential to be packed in biodegradable and compostable packaging, which is bio-based. Totally, it is almost possible to produce bio-based packaging with nearly the same or even same properties and performance to conventional plastic materials. Even through in a small-scale production, bioplastic application in food packaging are successfully implemented and covers all food packaging types: flexible, pouches, films, bag labels, and rigid, bottles, trays, cups, caps, cutlery packaging. PLA is applied for clear food films, trays, cups production. PHA is suitable for large food containers. Starch blends are used for pouch, films, and bags production. Bio-polyethylene and bio-PET drop-ins is an analog for fossil-based polyethylene and PET and can cover high barriers, properties, packaging, and beverage product group. By origin novel plastics, these plastics have a chemical structure like no other plastics. For example, PLA starch blends are used in food service packaging, cups, plates, food containers, cutlery, as most sustainable, organically recyclable alternative for single-use products that cannot be mechanically recycled, or when mechanical recycle is not feasible on site. One more thing which we are working on, definitely one of the barriers to implement the usage of biodegradable and compostable plastic materials and change the conventional plastics is the price. For this purpose, we are working and we're developing the mixes where we are using natural fibers to reinforce biocomposites. And we use the local agricultural waste like hemp fiber from the hemp fiber industry, grain bran from the country's grain processing industry, and we mix with a biodegradable plastic in order to keep the proper strength and also to reduce amount of expensive biodegradable plastic by using agricultural waste. And it really allows us to some research which we already did and recipes of materials which we produced gives us possibility even to put up to 40% of natural fibers, and it not affect significantly or somehow the mechanical properties of the composite material. Wrapping up the final messages from the trends of packaging and packaging material development. So less is more has a new meaning, and nowadays we need to use as less as possible materials in order to keep functionality. Climate change, plastic soup is new agenda for consumers. Bio-based plastics can contribute to lowering greenhouse gas emissions, especially with creating the bio-based plastics out of the food waste. Applications of biodegradable bio-based plastics is recommended in those applications where either a direct functionality or those who benefits. Very important thing that life cycle approach is needed. So we need to see whole life cycle, not only production or consumption phase. And what we say to industry that if we want to be innovative and propose for consumers the most innovative options, this is the time to use more research. So cooperation of research institutions, universities with the industry is only one way to achieve the significant global change in the market and to reduce the huge amount of pollution which is generated by packaging waste and which is indirectly affecting the climate change. Thank you for your
thank you very much, Dr. VISVALDAS VARŽINSKAS. If we have only one question we can take, if you have questions. And after the question, I want you to take a screen photo. Yes, if you have questions, we can ask, we can take one question. I think there is no question. Thank you very much to all presenters, all speakers. And we are very glad to meet you, and we are very glad to listen to you. So we have a limited time. So and Cansu, can you take a screenshot? Yes, if it is okay. So we have a break for 10 minutes, then we can meet at 4 o'clock again. Thank you very much. participants. Dear participants, we have two speakers in this part of our keynote speech. So the first speaker is DENI RUGGERI, Professor DENI RUGGERI, and he is speaking about when climate change adaptation meets social justice, landscape architecture students as agents of change in the SF Bay area. Professor RUGGERI, floor is yours. We are listening to you. Thank you very much.
Thank you for the invitation. I'm giving away some slides already. Well, first of all, thank you for inviting me, and it's a great. I haven't been able to participate because of the time difference, but I've been looking at some of the proposals and the abstracts and the titles of the conference presentations, and we are really aligned in terms of the challenges we are all sort of working on. And it's great to see all this great work that's coming from your part of the world. And so all of these challenges we are facing as landscape architects are not new, but they are now coming together, they're compounding themselves, and they challenge us in terms of how we think of our agency as landscape architects, but also I think in the way they challenge us in terms of what it says in terms of education, and how do we start to address some of these challenges in an educational setting. These challenges are what Mel Weber called wicked landscape problems. They're wicked problems because they defy simple solutions. They tend to be more about sort of, attempts at better or worse solution than finding the perfect, true solution to a challenge. They also don't allow us to any stopping rules or any exit strategies. Once we, once we imagine change and we implement it through policy design, there is no exit strategy. There's no way to sort of get out of it. And there's also no way to test immediate success. We can sort of measure the performance of what we do, but the ultimate success will be measured in landscape time. So in, hundreds of years. And so that presents us with some really interesting sort of conundrums. So the foundation of the work that I've been doing over the years, but also the work that we've been doing at Berkeley most recently, that I'm going to talk about today, is sustainable development. And the way we understand it today is a systemic understanding of sustainability. So it is, of course, about creating sustainable cities and communities that can, limit their impact on the environment. But it's also about all these other synergies with other goals of sustainable development, like the reduction of inequalities, the promotion of peace, which is very relevant, I think, in this day and age, or this particular time that we are in, addressing poverty and health, good infrastructure. So really the synergistic nature of sustainable development comes to life when we want to address some of the challenges that you all have been studying. And the good news for landscape architects, I think, and for anybody working with this interface between people and the environment, is that we have an entree into the landscape and the people, how people feel and perceive and experience the landscape through this concept of biophilia, which is not new, but it's Tim Bidley most recently talked about it as this innately emotional affiliation that human beings feel for other living organisms. And so I think if we can put biophilia into the work, or trying to address this kind of intimate connection that people feel with the landscape, there's a lot of benefits, will come out of it in terms of stewardship of the landscape and in terms of long-term resilience of the landscapes we create or we co-create with communities. So biophilia is an entree into it. And of course, I'm in the US, but I have taught in Norway and other parts of the world. And I think we're really, one of the things I've done here is to bring awareness in the schools that I taught about the European Landscape Convention, because it sort of set out in 2000 a very powerful statement here, a very powerful definition of landscape. as an area that is perceived by people, which is also the result of the action and interaction of natural and human factors. So this is a great recognition that there is an agency of individuals in shaping value in the landscape, and that agency is to be seen as also in conjunction with the way nature operates on the landscape. Another thing that I've been focusing on in my work in Norway and the book that I produced with Karsten, the late Karsten Jorgensen and Shelley Eagles, was the right to landscape. If it's true that landscape is defined by people, then I think it's important to start to mend breaches that we have created between some people, some groups, and the landscape. And so trying to provide this kind of right to landscape, both as an ultimate goal, have everybody having access to a landscape that supports them and their well-being and the well-being of the communities, and also the ability, the right to participate in the shaping of landscapes, the right to landscape. So the landscape with a lowercase l, which is about the daily practices that allow us to establish a right to the landscape. So the right to landscape, both as a goal and as a daily practice. And one of the things that I think has been important is to see design and to understand or try to problematize the way design works in the context of these global challenges. And of course, we're used to this, in past education and modernist or Beaux-Arts education to see design as this very linear sort of act that goes from analysis of a problem to a synthesis to a solution to that problem, and then the implementation of it. But the reality is very different. And we now understand design as more of a cyclical, iterative act of understanding a challenge, reflecting on it, collecting data to plan for sort of possible ways to address the challenges we face, and then observe the results and reflect upon them and make changes, incremental changes, so we can really get close to and improving our design and making it fit the challenges we are facing. So this idea of an iterative design process where information from communities and from scientists all gets implemented or introduced into the design process. And of course, this design process resembles a lot the way ecological processes work, which are all, and so if we accept this idea of resilience as these kind of cycles of adaptation and reorganization, then I think, design, the way we interpret it today, this kind of iterative process resembles a lot the way ecologies work as well. And finally, I think design, it's not just about creating solutions to problems. In fact, it's not at all about creating solutions. It's about trying to sort of propose strategies for addressing challenges, but these strategies mean nothing if they are not somehow communicated. And so storytelling is an important dimension of the work that landscape architects do in the communities today, because in the process of incorporating science and looking at best strategies to address climate change and other global challenges, we are also implementing new stories about the power that that communities have to sort of participate in changing the world. And so stories are important, and of course, landscape architects are visual storytellers, and that's something that we emphasize with the students. And that the coming together of all these theories, all these ideas, forms an image of landscape architecture as a transformative science of design, a transformative science because it transforms the places where it's implemented, as well as the people and agents that are involved in it. And it's a science, of design that incorporates research, innovation, technology, action towards equity, towards the right to landscape, as well as participation and co-creation. And so we are going to talk, I'm not going to have time to talk about the participatory dimensions of this work, but it's incorporating the native wisdom to the extent that's possible. And so I'm going to talk about some stories of change in the Bay Area, and this is the work I've performed with Christina Hill. Some of you, or many of you, are going to be familiar with Christina's work. She's a professor, associate professor of landscape architecture, and she's also the director of Climate Readiness Institute, which is essentially trying to implement not solution to climate change related challenges, but to implement strategies for adaptation and readiness at the regional, local, and site scale. And the starting point of Christina's work is really this, this map shows it very well. It's the interfacing of climate sea level rise and the sort of all the way it affects essentially our lives and the way we operate, you know, the way we conduct business as developers. And so with 16 inches of sea level rise, only 16 inches of sea level rise, you can see that in the Bay Area, many of the landscapes that the governments have been investing on, you know, as infrastructure for urban life, airports, highways, but also new ecosystems that have been, and marshlands that have been restored, and pipes and all this other infrastructure that's taking care of stormwater. All of these things will be flooded, and they will be essentially, they will make life extremely difficult for residents of the Bay Area. And it will make that life more difficult, particularly in the communities that are less, that have less resources. And this is where there's a little bit of a challenge here that, you know, we face. The Bay Area, if you see here, it's among many of the cities in the Bay Area located along the waterfront that we just saw with the climate change scenarios that, you know, I just introduced, are also some of the wealthiest places in the world. And next to them, there are low-income communities that continue to sort of have to operate in this landscape that is less affordable and much more unstable from an ecological standpoint. So the starting point here is of the work of Christina and the studio that we co-taught for the past few years has been to really try to tackle these challenges and to do it in a way that is collaborative, that it involves industry leaders, politicians, federal agencies, as well as residents and NGOs, so that the kind of transformations we need, this transformative dimension of landscape architecture, really can be leveraged and can lead to possible positive change. And the starting point has been looking at the water's edge, but looking in particular at the places that are most vulnerable from an ecological standpoint as well as an economic standpoint. And if you are familiar with the Bay Area, maybe you are not familiar with Marine City. I'm going to tell you a little bit about the story of this place and how it fits into this idea of a transformative landscape architecture. So Marine City is located in Marin County, just across from the Golden Gate Bridge. You can see it here. It's next to Sausalito. It's a very sort of tourist destination in the Bay. But the place has not always been the place that it is today. In fact, in the 1900s, this was a very rural area, you know, with agriculture and lots of sort of production, you know, environment, ecological sort of richness. That richness was essentially erased in the 1940s during World War II as a reaction to the needs of, you know, production for ships and other armaments. And in 1942, that's what the landscape on the left looked like. It was shipyards. They were created very fast, and they were set into, and they attracted populations from the rural south of the United States, particularly people of color who came here to find a job, and they lived in homes created, you know, next to the shipyards. When the shipyards left, this community remained. And they remained essentially housed in the same housing that the government had created for them in the 1940s. And this is the housing as it looks like today. It's been refurbished slightly over the years, but it essentially remains the infrastructure that was put into place in the 1940s. Very recently, Marin County, which is one of the wealthiest counties in the Bay Area, decided that the project, this housing complex, this housing district, of Marine City needed to be refurbished, and they proposed legislation and actions to remove essentially the population, move them out of their apartments so that the apartments could be refurbished, and then bring them back if they met certain kind of standards, which meant essentially displacement for many of the people that here live below, well below, a quarter below the poverty line of residents of the Bay Area. So we're talking about the poorest of the poor. And so with this displacement, we are also displacing, or we will be displacing a culture that has been created over the years. These people that have settled here, they made this place a home, they have histories associated, family history associated with it, and they have a strong connection and a strong commitment to making this place their home for life. And for the younger generations that are now taking over some of the older home owners' apartments. And so there is a pressure here for displacement that I think it's threatening them, in terms of not being able to probably find a home in other parts of the Bay Area. There is also an ecological challenge here of sea level rise that is affecting this community in a particularly unique way. You see here the Highway 580 runs through the community, and you see here there's only one way in and out of Marin City. And when the sea level rises, floods block the highway, and they block the only access to this community, making it impossible for residents to be safe. They cannot find doctors, they cannot travel outside of the community. They are essentially blocked into this island, and they have no way out. So a lot of the work that has been done a few years ago, we were contacted by the local community to try to address this issue by redesigning this pond here. There was a stormwater pond that was created in the 1960s and 70s when this new shopping mall had been put in place. And then by doing that, by redesigning this landscape, addressing issues of sea level rise and making sure that access to the community would be preserved. And one of the things that happened at the same time as the studio that we were teaching 2 years ago was the LA Plus Creature Design Competition, which we decided to sort of introduce into the course by challenging students to not think only about sort of sea level rise, but to think about the implementation, the ecological dimensions of sea level rise, also in terms of the species that reintroducing or connecting to a species that would find in this landscape a home. And so this is where essentially ecology and humanity meet. And so in this particular proposal, for instance, the students focused on reconnecting this kind of biophilic connection that people feel towards crabs. Crabs are keystone species. They're very important to the ecosystem because they allow then all these other birds, wildlife, and also grasses to, sort of remain and thrive. And so they are part of what makes this ecosystem so rich. And they are also much threatened by sea level rise because they need particular conditions to sort of survive, and particular grasses and vegetation to survive, which is being threatened by sea level rise. So a lot of the challenges, or the way that students address these challenges was to think about how through ecology we could then create a new connection to the ecosystem between humans and the ecosystem, and to do so in a way that would preserve the community, establish it here, make ground it even more here so that there could be no displacement. And one of the things that was really unique about this pond is that it's visible from the freeway. And so that explained why the community wanted to invest so much in redeveloping this pond, because it was a sign that they were there and they were there to stay. Another group took over an endangered species, the Ridgway rail. It's a native species of the Bay Area, and it's been threatened by the development along the water's edge. So it's a species that no longer, while historically this would have been a perfect site for it, after development, this species has not been seen in these landscapes for a long time. And so part of other groups of students focused on reintroducing habitat that will support this Ridgway rail as a sign of a re-establishing, a recolonizing of ecology and people of this particular landscape. And to look at it from and at the same time make it solve some of the issues like flooding and as well as stormwater quality. And so you see here the section at the bottom that shows these kind of filtering devices at the edge of the bay. And here's the community now, just a few weeks ago, meeting with the designer, Kevin Conger, to implement or to take into implementation some of the ideas that the students had produced for the community. And this is Miss Terry, who's a local activist, who's been very keen on using this, the fate of the pond as sort of a metaphor for the fate of the community. And across the bay from the landscape of Marin City is another city that has a somewhat similar history, but very different ecological conditions. This is the city of Richmond, California. And you see here an image of Richmond, California in the 1940s. This was, again, a rural landscape until the 1940s, or a relatively undeveloped land. But in the 1940s, with the war, it became another shipyard, lots of industry located here. And again, influx of people from the rural south of the United States, particularly people of color, that found in Richmond a perfect place to live, work, and coexist, not without sort of challenges. And this is the housing that was created for them, very blocky, very simple, very cheap housing. And that housing continues to remain today, to house today some of the lower income residents in this particular district. And you can imagine also the infrastructure that's aging now, more than 50 years after it was built. And so we have challenges here, not only to provide affordable housing, but also to make sure that the infrastructure and the armature of the infrastructure is functioning and it doesn't impact people negatively. So the geology of the place is particularly unique here. There's a fault line that with a question mark here, a line with a question mark, that it's hidden below, very deep into the ground. And the combination of that fault line and a lot of fill land, which you see here in pink, makes this place particularly vulnerable to, in the case of earthquakes, with homes actually being unstable, and and this is in combination with another challenge, which is groundwater related. It's not only about sea level rise; it's also about the impact of what that has in terms of impact on groundwater. So the groundwater is also rising, and so flooding may not be the result of sea level rise, or if we tackle sea level rise, we continue to have problems with groundwater. And that groundwater has implications of health, because a lot of the industry after World War II ended, small industry located itself in these lands. They were already they already had infrastructure, and they brought with them pollutants. And so this is an animation that the students created, looking at the testing sites of radioactivity levels and the interfacing of groundwater, sea level rise, and pollution. And you see here the spikes of pollutants that move into the landscape and through groundwater and affect homes, not only at the waterfront, but even well into inland. And this means that also gases and those pollutants are coming into people's homes through pipes that are breaking, and the seals of these pipes that are breaking and bringing gases that are very toxic to people. So here the challenge was, how can we bring landscape architecture as part of the strategy to address this? And so we did this by using technology and by communicating to the community what kind of technology, landscape technology, we could use. This is, for instance, the use of a hydraulic wall. The students here are testing the functioning of that wall, which is a way to block pollutants from moving with groundwater, and to remove, in some cases, very slowly, pollutants that may be already contaminating groundwater. The students also used this idea of a sponge park, the cleansing of water coming from the sea, which also brings pollutants during stormwater events. And so the idea that landscape could serve as sponges, as filters, natural filters for pollutants. And here it's about, the students are testing essentially the functioning of those technologies at a scale and that is perceivable and presentable also to residents. And this was presented to the community as a solution. And we are also adopting some solutions from other parts of the world, or strategies from other parts of the world. In particular here is the Dutch model of floating districts that have been implemented there, primarily to address this kind of challenge of sea level rise, pushing on groundwater and making it rise. And so how do you do that? By creating a system of super dikes and floating and moats, essentially by digging and piling. So the super dikes block stormwater, sea level rise from affecting inland, the places inland, but these floating districts also allow this groundwater to take its course and to adapt to the sea, the consequences of rising groundwater. And so you see here all the student work sort of combined into one collective sort of vision of reusing, or digging and piling, creating districts that are adaptable, that are resilient to sea level rise and groundwater rise, but also dealing with the soils and the excavation of those soils that are polluted, and trying to sort of prevent that pollution from migrating inland. And so you see here how the students had to sort of look into what could happen to that soil, the cubic yards, the large amount of soil that needed to be removed, and what would happen, how it would be cleansed, and then what would happen to these districts once the soil is removed, is the creation of these kind of floating districts that would allow affordable housing to be created that also is resilient to sea level rise. And these districts then, part of the work was also to encourage them to think of these districts not just as technical solutions, but also as good communities. And so thinking about sort of hubs for community life, commerce, economics, mixed use, and the location and transportation connections within these districts. And finally, ending with biophilia. And so while this kind of model needs to be implemented, it might take decades to be implemented, we also encourage students to think about, or to think about the biophilic dimension of this work. How we could actually create experiences within the landscape that can start to speak of this resilience, that adaptation. And so using these follies, or these kind of structures that could be used along some of the new trails that are being created in the districts to communicate to residents the instability of the sea level rise and how they can actually start to coexist and live with it. And part of the message here is that none of these strategies are strategies that would be implementable or applicable in the immediate, and that we need to think about this change, the change that we have in mind as in landscape time. And so we are here today. There's going to be a lot of work to be done, and there's a lot of time to for us to assess and reflect on whether we are successful or not. But change needs to happen, and I think some of the work that you are doing and some of the work that we are doing in the communities, bringing the best of this work together, I think it's the way forward. Thank you so much.
Thank you very much, Dr. Ruggeri, for your presentation and the valuable contributions related to a good project. And now our second speaker is Associated Prof. Michel Joachim, the work of architecture in the age of synthetic biology. He is speaking about this topic. So, Mitch, can you hear us? Yes, okay.
Yeah, can you guys hear me okay? Hi.
Yes, floor is yours, Mitch. We are listening to you.
It's good to see you again. Actually, two of you I saw. Yes, somewhere down there. I really wish I was there in person. I had a great time a few years ago, and I absolutely miss the food. I actually really like the food. I miss the culture, the atmosphere, and just the entire ambience of the place. And I don't know what happened with this pandemic, but I guess we're all online these days. But that being said, it's a good chance for us to at least communicate again. And hopefully, if anyone does come to New York, and I've said this before, please come and visit us, say hi. We're in the Brooklyn Navy Yard. It is phenomenal. I'll show a little bit of that, but I would love to connect again, have some coffee or beer, whatever, depending on the time of day, and hang out a bit. Things are pretty okay over here. So with that, I know that, there's a limited amount of time and you guys want to see some new work. So let me get this share screen thing going. Hold on a second. And yeah. And sorry. So as mentioned, my name's Dr. Mitchell Joachim. I'm an architect and urban designer. I'm the co-founder of Terraform One. These are just some of our recent publications that we have been working on over the years. The most recent one is Design with Life, which is represents over 400 people that have worked with us over the last 15 years. It's a detailed monograph of pretty much most of the work. So if you have further questions, this is a great resource to kind of find out that information. Sorry. Our kind of single overriding predicate for the work that we do falls underneath this mission, which is design against extinction. And that's remembering that every 9 minutes we lose another animal on this planet. That's every bird, insect, coral, mammal of all kinds are disappearing. That's about 60% of all actual wildlife since the 1970s has gone extinct. We are responsible for that, not maybe personally, but anyone in the fields of architecture, landscape architecture, urban design, urban planning. We're very much a part of that world that directs policy or allows this type of activity that happens that does diminish the habitat of a lot of these creatures. It's not only our fields, it's many others, but we certainly think that building back biodiversity is probably the most important thing that we can do. The type of work that we, or the type of method that we'd like to call it, is socio-ecological design. So this is recognizing that ecology and design are something both on the science side or on the authorship side we can completely control. The social side, such as the political class or the capricious public, is an entirely different deal. These are some of the range of projects that we operate on. They're pretty much at all different scales that work to design against extinction. Anything from furniture that is 100% compostable to sanctuaries for butterflies to different types of farm systems. So one of the first things I'm going to show is this project we did for the TED Countdown with the United Nations, which is looking at this 7-year plan until we see climate permanently changing and a 2-degree temperature rise, which would be devastating for the planet. So we produce these essentially eggs that have inside them cryogenically frozen embryos of a red listed species or a near extinct species. And the thought is to build awareness, to show communities that this particular organism in its particular location is on the edge of life and that we should probably do something about it. So contained inside here are all the nutrients those fertilized eggs would need to sort of jumpstart the population. After 7 years, they open up and would get a chance at life. It certainly would not save them by any means, but it's there as a kind of a representation or a semiotic pulse for change. Another project that works under extinction is this one here. It is a sanctuary for the monarch butterfly. These are native to New York City. They're absolutely beautiful orange and black butterflies. We built into the skin of this building facade system everything that looks the life cycle of these wonderful creatures. So here we call these biotope mosaics, and it accounts for the egg-laying stage, the caterpillar stage, the chrysalis stage, its relationship to milkweeds. We put a patent together. It's actually not only usable for butterflies, but over 400 different types of organisms that you can attach to the surface of an existing building and give biodiversity a chance in cities, or what we like to call rewilding. So here we have a pollinator garden, an education center on the rooftop. We've got a milkweed system in the atriums and inside the double skin facade. All of this is in service to keeping the monarch butterfly from going extinct. We've lost 90 million of these creatures in New York City alone. That is unbelievable. We probably have about 10 years before they're all gone. So here's a facade where you could see there are these large OLED screens that show the drama of the butterfly's life because they're rather small. So from far away, community can understand what's happening to them. We work with butterflies as our client. So here they are. These are painted ladies. Here they are in a study we're doing to see how the proboscis goes into a surface where they can get nutrients or drink. We had a system in place for years studying over 5 or 6 different butterflies in depth, and we work with entomologists both at the American Museum of Natural History and Cornell. This is the butterfly feeder system that we have produced for the American Museum of Natural History that's going up in their exhibition space currently. So it's a feeder that feeds them anything from dried fruits to areas for respite to actually Gatorade is something else they like. We work with large scale 3D prints for the design or the program of butterflies. These are intended to do studies to see how butterflies interface with geometry. These here are perch points or sleep points. We then used a 0 VOC silicone, that's a medical grade silicone, to take those 3D prints and produce molds. From those molds, we created a concrete that is structural, that would last 200 plus years, and that has the least amount of embodied energy and carbon inside it. Actually, it sequesters fly ash, it's put inside the system, and it's designed for butterflies. It's got areas for nutrient feeding beds, air quality zones, places of respite, areas for propagation. All of it is fit inside a double skin facade and meant to be inserted in the building. So here, when you look outside this building, you see this grand vertical meadow teeming with life, specially designed for the monarch butterfly, all kinds of areas for feeding and resting, et cetera, et cetera. And then we designed a fully operational facade mock-up, roughly around 2 tons, here for the triennial at the Smithsonian. And you could actually see the butterflies living inside this system, thriving. And it's also important to note that it's semi-porous, so they can move in and out of the system. They're not trapped inside there. There's all sorts of areas where they sort of like to rest, and you could, in your office space, look outside the window and check out your vertical meadow for these butterflies. Here they are resting on one of the coral zones. It's there for also air quality. And then we moved on to Los Angeles. We're working with ODA Architects. We're putting up a 65-story tower where the plinth of that tower is a parking garage. The entire parking garage is refitted with a double skin facade designed for butterfly sanctuary. So here you can see in the interstitial space that there's many areas for horizontal planting as well as vertical planting, irrigation systems, and all of these are designed for the El Segunda butterfly as well as monarchs, which are native to Los Angeles. So here you can see that system inside the parking garage. A modicum of maintenance is all it takes. It's not going to work nonstop every single day. You will need a gardener to attend to both landscapes on the surface of the roof, on the different balconies and on the ground plane, but also inside the facade itself. But this whole area is intended to help jumpstart biodiversity inside Los Angeles. So it actually works in a number of different places. So some of the things I like to show that move on just beyond butterflies is ideas about how we move and how we eat and how we live in cities, especially when it comes to thinking about the biology of ourselves and our cities as a whole. So here we're rethinking 42nd Street in New York, replace cars with trackless trains. We create these grand civic spaces, privileging pedestrians to walk inside our streets. We introduce a riparian corridor through the center. There'll probably be some insects, but that's okay. It's teeming with aqueous life. And then everywhere possible, we green facades and rooftops, or actually produce what we call productive green spaces. So it's not only for food or air quality, it's actually for energy production. So we'll have photovoltaics or vertical axis wind turbines, and then a modicum of maintenance provided by automated systems as well as humans. And thinking about how we could live in a biological way. Well, this is a project called the Hug and Kiss Lamb Car. Doesn't need to move that fast because 25 miles an hour inside places like Paris, Shanghai, or New York is pretty fast. I imagine that's super fast fast enough in Istanbul. And these cars are designed to be scuffable. So they're designed to actually occasionally rub up against one another. It actually won't kill you. It won't hurt you. The whole system is made of a series of air bladders. It's rather soft. It's drive-by-wire. And you're most likely not even driving anyway. You're probably reading your book. If you bump into someone, you just say ciao. And then another system working on vehicles in cities looks at stackability. So here the cars stand up and they interlock into one another. And you could park around 300 of these shared ownership vehicles on a New York City block as opposed to 30 SUVs or so. We productized one of them called the Heroku. It's around 28,000 euros. You can see the wheelbase looks a little strange. That's because it is. It's an omnidirectional car that stands up. So it reduces its footprint for parking, about 30% smaller than a Mercedes smart car. The ingress and egress is through the front, so you don't access it through the sides, but you go directly onto the sidewalk by going out of the front of the vehicle. And this is really a car designed for cities, not the entire 20th century designed around the automobile, but a vehicle as a technology designed for cities themselves. So this is the lab where we do a lot of this work here in New York City. It's in the Navy Yard, and Terraform One is in this facility. It's a facility that houses many other disciplines and companies together. So we work in waste, food, water, energy, mobility, and equity. We have areas for material libraries, fabrication zones. It's kind of a cathedral for design and making. The last time I remember, you guys had produced probably the most impressive school of architecture I'd ever seen in some massive grand building. I think that's online recently. Well, we're doing that in New York, but not to the same scale you guys have done, but this is the space that we're in. Terraform is one of the few architecture offices there. Everyone else is in some kind of a technology company, and we blend in seamlessly or synergistically with all those different groups to work on projects that cross many different platforms and disciplines together. So the Terraform space itself is kind of like where the atelier meets the science garage. So it's constantly experimenting, it's building and making things, and also doing stuff as a part wet lab, part physics area, part zoo. It's quite an interesting zone. Here we are working in vertical farming with another company, Farm Shelf, that's next to us, doing a lot of work in hydroponics and grow lighting. We also teach folks. So we run a group called One Lab. You could come to the Brooklyn Navy Yard and we have classes over the summer. You could check out the One Lab website, but here we teach you how to make your own machines. In this case, a thermoformer. So not only do you get to know how to do thermoforming, you can actually build your own thermoforming. We also do rooftop farming and gardening. Here's pectin impregnated soils that are super lightweight, made out of clay material, so you can garden on your roof. Also looking at phytoremediation, not just putting phytoremediation in a rendering, but you get a chance to build your own phytoremediation pond and then see your gray water slowly get cleaned over time. We also have one of the only, now there's a lot more of them, but at first we were one of the only molecular cell biology labs. This is my roommate from Harvard, Dr. Oliver Medvedik, who runs the Kembar Center for Bioengineering. And you work side by side with artists and architects doing things like projects in genetics. So it's not just architecture, it's actually really bleeding into many other disciplines and scientific mindsets. A lot of this research falls under what we call ELM, or engineered living materials. These are essentially structures composed of living cells that form or assemble materials to modulate their performance. These are some, I think, diametrically opposed examples of ELMs, or engineered living materials. The one on the left is the Willow Cathedral in Britain, and the one on the right is the Bick Building with a facade made of algae by Ove Arup. Both, well, I'd say one is technotopic while the other one is ecotopic. There's a whole range of areas one can study living materials. This project does just that. So here we're working with transgenic E. coli as a way of mapping population growth to cities. This is actually a map of Istanbul existing and then projected in two different transgenic E. coli colors. So we map the exact amount of population that exists, and then the projected population by the end of the century. The exercise was intended to show how many people on this planet, it would show how many people on this planet live in cities, what are the densest cities, and what does 11 billion humans look like by the end of the century. So we worked very carefully with the coli to design it into different systems to control its shape and its growth and the amount of colonies, population colonies that it produces. Here we chose the 50 densest cities on the planet Earth. Istanbul was one of them. We then placed it on this parametric map showing the cities growing out of E. coli from existing populations to future populations. And then the system had applied USB microscopes at 400 times magnification that show what that looks like. And then on the other side of this map was a parametric model that is also a graph that shows the growth of those cities in their particular location. This is actually based on Buckminster Fuller's Dymaxion map, if that's not obvious. You can see most of the world's cities are growing in Asia, while actually those really dark spots are shrinking city zones. Then moving on to other biological materials besides E. coli, we are working with Acetobacter and Mycelium. This is a novel biopolymer that we had produced. It's essentially bacteria-expressed cellulose. And we made a chair for my daughter's kindergarten. This is a chair you can eat, which is crazy. You can eat your crayons, you can eat glue, and I guess now you can eat your chair. This was made of 21 separate molds. It is completely organic and compostable. It combines Acetobacter and the root base of reishi or a mushroom. So it's a mushroom chair and an Acetobacter chair combined. We made an adult version here at Chaise Lounge. This is made with plyboo, or basically plyboo or a type of bamboo plywood ribbing system, and it's filled with agricultural waste. It's then acculturated and grows into a chair after 7 days from mycelium. So it's a triply curved structure, completely made out of mushroom. When you're done with this chair, you throw it into a garden and it feeds thousands of other forms of life. We've got some of these chairs that are 10 years old. They look great. If they chip or break, you can just regrow a small section of it. We look at the metabolic metrics of cities. Like what do they actually mean from the perspective of flow or data? So here, this particular image is actually the Statue of Liberty. It represents 36,000 tons of trash every single day in the city of New York. So that's basically what we produce. Something like the mycelium you saw from the previous project could replace that. And we look at different technologies. Here is Amazonian mealworms. They actually eat styrofoam, which is one of the worst forms of urban waste you can have. There's a project done out of Stanford, and it looks at how the mealworms completely consume the styrofoam. They actually digest it twice, turn it into frass, and then eventually it becomes mulch that goes into your garden. So mealworms became our client. So if it wasn't E. coli or butterflies, we had this guy as a client. They eventually turn into adult beetles that feed birds and other organisms in the area. And we produced a digester with the Bloomberg Foundation for the city of Camden. So here you throw your urban waste, your e-waste, into the belly of this digester system, and the mealworms eat it. So it's part architecture, part public sculpture installation. And it's showing you donate what it's actually located on an urban junk space where a lot of waste is produced. It has a clock on the top that shows how long it takes to naturally decay something like styrofoam, anywhere from 500 to 1,000 years, and then decaying it when you're using mealworms. It takes only a matter of a few weeks. The entire left side of that project is a farming system for mealworms themselves. So we're growing thousands of mealworms that then eat the styrofoam. Then after they're done eating it, we use the mulch, which is left over, into the garden, and then the beetles feed all types of reptiles and birds and help build in biodiversity in that area. A lot of the bins are empty, and that's okay. The bins are meant to be filled with different types of plants and hyacinths and other kind of weeds for that area to attract different kinds of animals. That's a section through one of those mealworm farming systems that lets you see the frass trays, the trays for the eggs and then the adult worm itself. And we grow them in place. This shows you the clock with the different time signatures. That allows you to see how long it takes different materials to decay. That is the oculus going through the roof that actually builds up the stack effect and cools the whole system. And here you see the mealworm farm and the biodigester in the center. This is actually an image for the press where they came to check it out. It's in a very, very poor area just outside of Philadelphia. It's a challenged community that really wanted a project that addresses waste in cities. And getting on to another type of engineered living material. This is woody plants grown into specific geometries. We actually grow them into long roots, and these tap roots can be shaped. They're super pliable onto scaffolds. And those scaffolds will give you almost any geometry. We attach them to old growth trees. So those are existing trees, and you have a home that fits into the landscape where there's no distinction between the landscape and the home. And we're on many different types of these bioreactors to grow those plants into the longest possible taproot. So here we're doing ultrasonic misting and different types of UV lights to color those areas and then basically have long, healthy roots. And then a more recent study, we actually found that we may not even need to even bother growing the roots. So here in most parts of the United States and in Europe, we produce biomass to create fuel. So these willows are grown 5 meters in length, pelletized and burned as a renewable source of fuel. Well, instead of going from farm to fuel, we actually want to go from farm to construction, use these willows to build homes. So this is a modular truss system with CNC cut components that fit into a complex geometry with those very same willows that are clustered together, grafted, and woven into a shape. So on day one, we don't have to grow the different woody plants. It's actually on day one, the willows are fitted into the scaffolding, and you get these complex diagrid holes that are built out of an engineered living material. Here you can see this was a model we did for the biennial in Vienna at the MAC Museum. You could see this home is 100% made out of growing components or plyboo, and then it's attached to old growth trees. The concept here is to have the first ever engineered living material home growing in upstate New York. The windows are made of an algae similar to the Bic building. It's also adjacent to a horse farm. And it's great here. You can get a kind of a sense of scale with those two horses in the area. So there's a central core that is more or less the kitchen and the toilet areas, which are made out of a low embodied energy CLT. And then the living diagrid systems spin off from that central core. We took those same systems into a vertical tower that was also a farm. Here we're using Ficus sycamoris, attaching them to a larger diagrid on a mass timber frame, which is a great thing to construct with. It has the lowest possible embodied energy. There's different planters there on the surface of the building, and we're producing this garden tower for King Salman Park in Saudi Arabia. So here the landscape actually goes into the building and up the surface of the building. The infill is made up of a structural woody plant ficus, and then it's highlighted or accented with different planters. It is all made from material plants that are actually drought tolerant and can survive dust storms. And the building itself is skinned in these diagrids. And then all of the infill with the woody plants kind of ends the garden effect. In the inside of that building, which I'm not going to show, the main function is a vertical farm, which is something that the client had asked for. And finally, the last two projects and our clients, the cricket shelter and the farm pod. So this guy and thousands of them just like it became our client. The intention was eating this, but not exactly this guy, a powderized version to get protein in cities instead of protein produced on cattle farms. We compared the same amount of surface area for producing meat in a rural community versus producing protein from insect powder inside a city. And you can see from the same amount of acreage, and the same amount of protein, you'll save roughly 300 times less greenhouse gas emissions and 2,000 gallons less water per gram of protein. We worked with technology called architecture to think about the lives and the health of these crickets, giving them the best possible life they can imagine. Produced this cricket farm and shelter that's designed for the life of the cricket. They live 6 weeks, and then they're harvested. They die naturally, and they're turned into bagels, bonbons, pasta. We worked with Michelin-rated chefs. We fed them orange peels and lime rinds and apple cores to change the flavor of the cricket itself. And then once they die naturally, they're powderized or milled into a powder and turned into a whole host of a very juicy, brilliantly tasting protein. The best pasta I've ever had actually came from these organically grown, super hygienic, super sanitized crickets. There's a section through the system. Those spiky bits on the top are actually wind cowls that magnify the sound of the crickets. So as the males chirp, which they often do when they feel safe and happy and want to reproduce, instead of the wind coming out of the shelter, it actually magnifies the stack effect that's happening on the inside and turns the volume of the chirping louder. So you can tell that the shelter is happy because it's literally singing with all of those crickets, reproducing, having cricket babies, and living a healthy life. Here we show some of the pod structures. These pods are meant to help the crickets procreate. Here's a detail of one of those cricket sex pods where they distribute their genetics throughout the entire system. And then finally, the last project, because I know time is limited and I think I'm one of the last to go today, which is, it's an honor to be the last word in the conference, I guess, but I will take some questions and answers if there's time for that. This is our project called the Plug-in Ecology, the Urban Farm Pod. Here it's growing food on a sphere instead of a wall. So instead of a green wall, it's a green ball. It's a rotegrity sphere, so it comes flat packed. You can then easily shape it into whatever size that you need, from 14 feet to 4 feet. Then the panelization system is made out of these pleated structures that are folded into place, where you could then put inside your double skin potting elements and grow your food. So here we have wheatgrass and spirulina. You would want to grow stuff that's high yield, like mints or arugula. You don't want to grow stuff like corn or wheat. That could be done someplace else. The stuff you want to have fresh and fast, and want to have a connection between pasture to plate. You want a relationship between the food that you eat and where it comes from. So this farm pod is part farm, part furniture, part shelter. Not only can you grow food on the outside, you can also grow food on the inside. So it's got 9 columns of sub-irrigation. It trickles down to a cistern at the base, and then that recirculates the water back up to the top. It's actually on the base of it also has grow lights that are controllable with an app. And there's a wheeled system that allows you to turn it to get the most amount of solar income. Anyway, that's just some of the projects we're doing at Terraform One here in Brooklyn, New York. I hope that sort of answers some of the ideas about biology and architecture and urbanism. I certainly enjoyed being there the last time, and it's great to reconnect with you guys. So happy to do Q&A, or I don't know what the format is now, but thanks very much, guys, for listening. And I'm going to stop sharing at this moment and get back to just me. Or did it stop that? No. Whoops. What? Oh, I stopped sharing. Oh, there we go. Okay,
Mish, thank you very much for your joyful presentation and interesting projects, of course. So if you have permission, we can take questions if our participants have any questions. You can ask to Mitch. Yes, I think, I think there is no question. Yes, Doğan has a question.
I will not ask a question, but I would like to say something about the 2 amazing guys. Hi, we miss you so much. And I would like to invite you again to our city. We should do something again with you. Maybe a workshop, maybe a symposium or some other project. Yeah, it's very nice to see you again with us here.
Yeah.
Thank you so much.
Yes, thank you so much. We share the same feelings, and as soon as possible, we must see we meet together in Erzurum or anywhere. As Doğan said, we miss you much, and our students are with us, and they are listening to you, of course. And thank you very much again for your sharing, for your projects, and for your information.
You're very welcome. None of the students have any questions. Do they even understand what I got? A lot of thank yous, which is
yeah.
If you actually want to know more, just go to our website, send me an email. I'm at mj@terraform.org. Happy to answer emails. I mean, that's what professors do. I've seen that's like our basic function, answer emails.
Okay. I will share your email address to everyone. Okay.
Yeah. Good.
Okay.
Thank you.
Okay, thank you very much. This is the last session, and dear participants, I want to make a closing session speech. If you have time, not so long. So I want to thank to someone and some committee members. Then I will close our symposium. And first, dear distinguished scientists and students and my colleagues, I would like to thank to you for your priceless contributions to our scientific event. I also present my special thanks to our organization committee with the coordination of Dr. Doğan Dursun, Defne Dursun, and Merve Yavaş, our research assistants who took part in the event, the chairs of the sessions, faculty members, our students from all graduate levels who followed the presentations carefully. I also want to declare our satisfaction for the participation and contribution of our valuable keynote speakers. Their participation and speeches attract great attention because we received great demands for the records of these speeches from various fields. In a 2-day dense and tiring marathon, we listened more than 100 presentations at 23 sessions, including opening and closing ceremony, of course. We also watched 3 valuable videos, one of which is from our keynote speaker, Professor Manu Sopti, and the 2 from a documentary filmmaker, Mr. Yavuz Özer. We present our special thanks to him. And our keynote speakers are Muhammed Rahimi from Iran and Adep El-Kaid El-Ameri, Emine Didem Evci Kiraz, Cenk Demiroğlu, OSMAN BALABAN, ANDREAS MATZARAKIS, ABDULLAH KAHRAMAN, VISVALDAS VARŽINSKAS, DENI RUGGERI, and Michel JOACHIM. We are grateful to you, and we also present great thanks to you. And presentations and speeches come from both climate and bioclimate sides, as we expected. We spoke about the effects of climate change on human-made and natural areas, possible future trends of bioclimate and climate change, its impacts, their direct effects on cities and cities' effects on climate and bioclimate, human body and public health, economic sectors, social and psychological capital, awareness level towards climate change. Turkey, as the country, is at the breakthrough for climate change matters because we are experiencing more or less the impacts of climate change all across our country. As forest fires or extreme weather events, we are now experiencing them. We think we achieved some positive steps and hope that such scientific events and their results will be valuable for first our decision makers and then all over the world. It's an altogether challenge to struggle with climate change. So we hope we succeed to be part of this togetherness. I again and again present my great thanks to all participating researchers and students and committees. Thank you very much for being with us, and thank you again. Dr. Doğan Dursun, do you want to say anything?
No, I think we can get a photo. Everybody can open their cameras.
Okay. We can take a family photo screenshot. Cansu, can you take it? Okay. And we will share this photo through our website, at Atatürk University's website. So thank you very much to all our participants.
Thank you.
Okay, thank you very much again. See you then. Bye. Bye-bye.